Let's begin with the softest question that hides the biggest answer. What is space? We're used to treating it like a black backdrop where stars hang, a quiet stage that holds the show while planets and comets play their parts. But space is not a stage you set up and forget, it's part of the cast. In Einstein's picture, space is woven together with time into a single, flexible fabric, space-time that bends and ripples when mass and energy are around. Gravity isn't a mysterious pull so much as the shape of the terrain. If that were all, it would already be dreamy. But zoom in, far beyond atoms, and the empty between things turns busy. Quantum fields pervade every particle you've ever heard of is a tiny ripple of its field, and even when no obvious particles are present, the fields never fully sit still, they jitter. Little pairs of virtual particles flicker into existence and vanish again too quickly to grab, yet their effects can be measured. This fume is called vacuum energy. From far away, the vacuum seems calm. Up close, it's a restless sea. Space isn't nothing. It has properties, energy, temperature, geometry that evolve. It stretches, curves around stars, and carries whispers from the Big Bang. So when you hear our video's sleepy question, does space end? Remember this first truth. Space isn't just where things are. It's one of the things that exists. It participates. It shapes and in the stillness between your breaths, it's quietly active, like a cat pretending not to watch you from the doorway, unblinking, everywhere, patient, and very much alive. It is the fabric our story moves through, the question and the setting, the lullaby and the pillow beneath it all tonight. Stand under a clear night and the sky feels endless, but our vision is wrapped in a gentle bubble, the observable universe. It isn't a wall, it's a limit set by time. Light's fast, but not instant, and the cosmos has only been shining for about 13.8 billion years. Because space itself stretches while light travels, the farthest galaxies we can detect are now about 46.5 billion light-years away in every direction, a sphere roughly 93 billion light-years across. That mismatch, what in 8 versus 46.5, comes from expansion. Think of raisins in rising bread. A photon launched from one raisin toward another leaves politely on time, but its destination drifts away while it's en route. The trip is longer by the time it ends. Our bubble is defined by what has had time to reach us, not by where the universe stops. This horizon grows. With each passing year, fresh light from slightly farther places finally arrives. Yet there's a bittersweet twist. The expansion is accelerating, so some galaxies are receding so quickly that the light they emit now will never reach us at all. We can see their ancient glow today, but their current stories are already beyond our future. When you whisper "does space end" to yourself, picture that patient sphere around you. It isn't an edge, it's a clock. It changes as time passes, and inside it live perhaps 2 trillion galaxies, each with its own storms, dawns, and quiet midnights. The observable is our cozy snow globe in a wintry room we can't fully see. It's enough to study, enough to wonder at, enough to fall asleep beneath, and a promise that tomorrow's horizon will be just a little wider. Beyond it, reality may continue forever or curve quietly back on itself somewhere unseen. Every twinkle is a time machine. A star 100 light-years away is sending you a century-old postcard. Galaxies billions of light-years distant are delivering photos from before Earth had oceans. Astronomers describe this with look-back time. How far into the past we're peering when we measure an object's light. The deeper we look, the younger the universe appears. On the road to us, wavelengths stretch because space stretches. That shift toward longer, redder light is called redshift, the optical echo of expansion. Measure the redshift and you learn two things at once: distance and history. High redshift means far away and long ago. With powerful telescopes, we now glimpse primitive galaxies whose glow left when the cosmos was only a few 100 million years old. This layering of ages turns the sky into an archive. Different directions show different chapters, nearby spirals in mature starlight here, faint baby galaxies over there. Some of the objects you admire tonight may have already merged, faded, or slipped beyond sight. We see their ghosts, which is a gentle kind of magic, true and gone at once. Though space in drifts through this too. Because if light is always late, then endings are always delayed. We never catch the present at cosmic distances. We only gather memories. But those memories are generous. They let us reconstruct the universe's biography, page by page, color by color, and in the quiet hours when you're falling asleep, they remind you that even the dimmest speck above you might be older than mountains below you. The sky is a museum of time, open nightly, free admission, no lines, and every visitor leaves with a small, quiet souvenir of wonder tucked gently behind their closing eyes tonight. On Earth, a horizon is where land kisses sky. In cosmology, horizons are clocks and limits, not fences. The particle horizon is the farthest distance from which any signal could have reached us since the beginning. Because expansion lengthens the journey, that distance is about 46.5 billion light-years in every direction, defining the perimeter of our observable universe. There's another, more poignant boundary: the cosmic event horizon. It marks places receding from us so swiftly that light emitted there today will never arrive, not even given forever. They are visible now only because of light launched long ago. Imagine waves rolling toward you while the shoreline itself recedes faster than the waves can crawl. That's the event horizon's melancholy geometry. Sometimes people say cosmological horizon to mean these observational edges together, the shifting border of what information can reach us. None of them are walls. They're patterns in time, woven by expansion. As ages pass, our particle horizon grows, more light completes its marathon. Meanwhile, accelerated growth makes the event horizon ever more decisive. More galaxies slip beyond tomorrow's knowing. Where does this leave our bedtime question? Does space end? Our horizons don't answer that. They answer only how far our news can travel. Beyond them may lie endless more, or a subtle curve that folds back like a whisper. Horizons are lessons in humility. We live inside a grand fog that thins a little each day, and that's enough. You don't need to see the whole ocean to fall in love with the tide. You only need to listen to the water and trust that more is out there, even if it's fated to remain forever out of reach, sailing past the edge of knowing with lanterns we can never touch. Edwin Hubble noticed a pattern in the starlight. The farther a galaxy, the redder its glow, the faster it recedes. The simplest reading is also the strangest. Space itself is expanding. Don't imagine fireworks exploding into emptiness. Imagine dough rising. Galaxies are like raisins in the loaf. As the dough swells, every raisin watches the others drift away, not because they're crawling through the loaf, but because the loaf grows between them. Rewind that movie and everything squeezes closer and hotter until we arrive at the Big Bang, not an explosion in space, but the rapid swelling of space everywhere at once. Fast forward again, and the surprise deepens. In the last few billion years, the rise began accelerating. Something dark energy is pushing the expansion faster, a gentle pressure baked into the vacuum itself. This growth is selective. Gravity and other forces hold small things together. Your coffee doesn't drift from your lips. The solar system doesn't stretch. The Milky Way remains a bound city of expansion, operates in the wide deserts between galaxy clusters where space can lengthen without tearing what's glued. Does this mean space ends? Not by stopping, but by outpacing. Far away, recession outruns light. Signals launched today in those regions will never reach us. To watch the universe is to cherish the present glow, while knowing the current chapter from many galaxies will forever go unread. If that sounds sad, try the gentler view. We're inside a bakery at dawn. The air sweet with possibility. The loaf rises, the room fills with aroma, and every minute presents a fresh slice to study, warm, detailed, and perfect for late-night pondering. The rest will remain in the oven, and that's okay. Tomorrow new crumbs of light arrive, and the story grows again. Relativity sets a speed limit. Nothing moves through space faster than light. Yet astronomers talk about galaxies receding faster than light all the time. No rules are broken because it's not motion through space, it's growth of space. Picture yourself walking up a down escalator. If the steps slide downward faster than you can climb, the distance between you and the top still increases. Light is the walker. Expansion is the escalator. In the very earliest instant after the Big Bang, a phase called inflation likely made space swell stupendously fast, enlarging the young universe far beyond what light could cross. That rapid stretch smoothed wrinkles and spread tiny quantum fluctuations into the seeds of galaxies. Inflation isn't a spaceship, it's a fabric maker, pulling new cloth from nothing in breathtaking speed. Even now, far-flung regions separate faster than light because the metric, the ruler built into space-time, keeps lengthening. That's why some galaxies we see today are already gone, in the sense that any light they emit now will never catch up. We observe ancient taillights curving around a bend, aware the car has turned onto a road we can't follow. Does that mean space ends? Not really. It means space can outrun messages. The universe draws curtains not with walls, but with speed. And there's a soft comfort in this, like a bedtime story you never finish. The part you heard was enough to dream on. Tomorrow night, new pages arrive from nearer chapters. The distant epilogue sails away with dignity. Close your eyes and imagine the escalator slowing to a hush, while the lights of local stars keep you company, faithful, steady, beautifully within reach. Somewhere beyond, the music continues, but this room is quiet, warm, and perfectly sized for gentle wonder tonight. Geometry guides destiny. On huge scales, space could be flat like an endless sheet, closed like a three-sphere, or open like a saddle. In flat space, parallel lines never meet, and triangles summed in a closed universe travel far enough in one direction, and eventually you'd return to where you began. In an open one, lines diverge, and the whole terrain feels Pringle curved.
Which version we inhabit depends on the average density of matter and energy compared with a critical value set by gravity and expansion. Measure the early universe's faint afterglow, the cosmic microwave background, and you can infer this geometry by how ancient ripples scale across the sky. With remarkable precision, observations say our cosmos is very close to flat, at least across the part we can see. Flat doesn't force infinity. It just allows it. A flat universe might still be finite if space loops in clever ways, and a closed universe can be finite, yet unbounded, like Earth's surface lifted into 3 dimensions. No edges, no outside, just a smooth return after a very long trip. How does this soothe the question, do space end? It replaces cliffs with curves. There might be no out there to fall from, only roads that bend you home, or there may be no homecoming at all, just an ever-unfolding plain. Either way, edges are optional.
Space can be complete without borders the way a melody is complete without a wall to lean on. Let that idea rest under your heartbeat. The universe may be round, flat, or open, and still be wonderfully edged. You don't need a railing to feel safe here. The geometry itself holds you gently, while constellations trace their quiet chords and the night slips, measure by measure, toward a soft cadence. To picture curved space, imagine ants living only on the surface of a balloon. They can walk north, south, east, and west along the skin, but they cannot dive inside or float above. Their world has no edges. If they wander straight long enough, they loop back home without ever turning around. That's finiteness without boundaries. Space that is complete yet edgeless. Now enlarge the idea. Our three-dimensional space can curve intrinsically without needing to sit inside a bigger container. It can expand too. Paint tiny dots for galaxies on the balloon and inflate it. Distances grow even though the dots don't crawl. There's no center on the surface. Every point watches every other point recede. Likewise, in the cosmos, expansion happens everywhere at once. There is no privileged middle, just local neighborhoods bound by gravity while the wide boulevards between them widen. Curvature also bends light. In curved space-time, rays follow geodesics, the straightest possible paths, which are often not straight at all. Massive objects act like glass lenses, magnifying, distorting, and sometimes multiplying background galaxies. The universe becomes a slow-motion funhouse mirror that tells the truth. Does this picture answer whether space ends? It suggests a different question. Does the path ever stop? If the geometry brings you back around, then the journey is endless without being infinite. If it stays flat and open, the trek continues forever without a return. Either way, there's nowhere to fall from. You walk, you look, you rest. The night air fills your lungs. Somewhere a distant lens is bending starlight toward you right now, and all you need to do is blink slowly and let it arrive. The cosmos will keep its promise. More light, more paths, more quiet miles to dream through each night. Infinity isn't a number, it's a posture. A truly infinite universe would hold unending stars, unending dust, unending chances for patterns to repeat. If matter is sprinkled fairly, the math hints that somewhere inconceivably far away there could be another patch nearly like ours, maybe even another you choosing a different midnight snack. None of those twins are visitable. Their light will never reach us still. The idea stretches the mind like a deep breath. Do our measurements demand infinity? No. They say large and very nearly flat. That leaves room for infinity and for very big but finite. A perfectly flat map can still loop in clever topologies. A gently curved cosmos can end its volume without ever producing an edge. You don't need a cliff to stop walking. Sometimes the path circles. There's practical humility here. We test only what can reach us. We can put no ruler on the unreachable. The observable universe, our glowing snow globe, already contains enough sky to keep 1,000 generations busy. And if the whole extends without end, that's beautiful. If it closes elegantly on itself, that's beautiful too. So does space end? Maybe it never ends in the way our hands expect. Maybe the end is a concept we brought from rooms and fences. Space might be finite but edgeless, or infinite yet forever partitioned by horizons. Tonight, you don't need a verdict. Let the word infinity soften into a feeling, wide, calm, and patient, as the sea at 3 a.m. when the only certainty is that the waves will keep arriving, and if answers must come slowly, that's fine. You are already afloat, rocking gently on a universe big enough to hold a question for a lifetime and still leave room for dreams, and tomorrow night too. We're trained by doors and fences to expect borders. Cosmology keeps whispering, you can have completeness without them. A space can be finite yet lack an outside. Mathematicians call this unbounded. The classic two-dimensional example is a donut's surface. An ant can walk forever without meeting a wall because the path wraps around. Translate that to 3 dimensions, and you get compact topologies that connect back on themselves in directions your intuition doesn't practice. Video game maps offer a helpful toy model. Walk off the right edge, appear at the left, fly upward, return from below. There's no edge, just continuity sewn cleverly. Could our universe be like that? Perhaps. People have searched for repeating mirrored patterns in the cosmic microwave background that would betray a small, multiply-connected cosmos. So far, no smoking gun wallpaper. The universe we see looks big, smooth, and very nearly flat. But the key lesson remains. Nothing demands a border. Space can be whole without an outside. Here's a softer way to hold it. While you drift toward sleep, imagine a long hallway where the carpet loops seamlessly. You stroll and never sense a seam. If the loop is enormous, you might never notice at all, not in 10,000 lifetimes. Does the hallway end? Only as an idea. Your feet can keep going. So when the thought, do space end, returns, let it pass like a breeze at the window. Edges are a habit of rooms. The cosmos may favor curves and connections. Whatever its global shape, your local patch is generous. Moonlight on the floor, starlight on the ceiling, and enough mystery between them to last the night. Sleep on that and wake knowing the hallway is still there, patiently unrolling beneath your next curious steps into morning light. Before stars learned to shine, the whole universe glowed. As the young cosmos expanded and cooled, a moment came about 380,000 years after the beginning, when charged particles finally calmed enough to pair up into neutral atoms. Suddenly, light that had been ricocheting like pinballs through a fog of free electrons could slip free and travel. That first free light never stopped. It has stretched with space for 13.8 billion years and now arrives as a faint, uniform microwave warmth bathing all directions. The cosmic microwave background, a lullaby left on repeat since dawn. At first glance, the CMB is astonishingly smooth, the same temperature everywhere to a few parts in 100,000. But zoom in and tiny hot and cool freckles appear. Those specks are the original seeds of structure, slight over and under densities in the primordial soup that gravity would later amplify into galaxies, clusters, and the filigree of the cosmic web. We've mapped this ancient glow with exquisite instruments, Kobe, W-map Planck, reading its ripples like grooves on a vinyl record. From them we infer the universe's age, its almost flat geometry, and the proportions of its ingredients, ordinary matter, dark matter, and the even stranger dark energy. The pattern also hints that space is remarkably uniform on large scales, as if an early burst of rapid expansion smoothed the wrinkles before letting time proceed. Does the CMB tell us whether space ends? Not directly. It tells us how the part we can see began and how it has stretched. It's a baby picture, not a map of the whole house. Still, there's comfort in knowing the same ancient light drifts through your room tonight. Quiet, invisible, steady, carrying a story that never quite finishes, even as your eyes do. How far is far? Astronomers build distances the way hikers build climbs, one step at a time. Nearby, we watch Earth sweep around the sun and measure a star's tiny yearly wobble against the background parallax, a thumb's width trick scaled to the sky. Farther out, we rely on standard candles, objects whose true brightness we can infer, so their apparent dimness reveals their distance. Cepheid variable stars breathe with clockwork rhythm, period. betrays power, power yields distance. Type 1a supernovae, stellar endings triggered by a white dwarf overeating, reach nearly the same peak brightness every time. Calibrated by Cepheids, they extend our measuring tape across deep space. For the farthest reaches, redshift, the stretching of light's wavelength by expansion, becomes the ruler, turning spectra into mile markers. Layer by layer, these rungs form the cosmic distance ladder. Each rung is tested against the ones below, so the whole climb stays honest. With it, we chart the Hubble flow, how recession speed increases with distance, and sketch the universe's expansion history. The picture that emerges is both precise and poetic. A cosmos that grew, cooled, formed stars, then to our surprise, began speeding up again. Does a good ruler find an edge? Not necessarily. The ladder tells us how the landscape behaves, not how far it ultimately goes. Think of it like walking a coastline in the fog. Your GPS is accurate, your steps are true, but the beach keeps curving out of view. That's okay. The joy is in the mapping itself, the careful stacking of methods, the patient cross-checks, the way a star's gentle flicker can become a yardstick for billions of light years. Tonight, let those rungs settle under you like a stairway to sleep, firm, repeating, carrying you upward into quiet. Part 13, 100, the night the universe blinked faster. In the 1990s, two teams set out to measure how much the universe's expansion was slowing under gravity's pull. They used Type 1a supernovae, those standard candle explosions, as beacons, comparing their redshifts and brightness to reconstruct cosmic history. Everyone expected deceleration. Instead, the data whispered a different story. The most distant supernovae were dimmer than predicted, as if they were farther away than a slowing universe would allow. The universe wasn't breaking, it was accelerating. This jolt became one of modern astronomy's quiet thunderclaps. To make sense of it, cosmologists revived an old term from Einstein's notebook, the cosmological constant, an energy baked into empty space that pushes everything apart. Whether that push is truly constant or the sign of some evolving field we call dark energy, its effect is unmistakable in the curves of the data, the patterns of the CMB, and the large-scale clustering of galaxies. The loaf isn't just rising, the yeast has a tailwind. Acceleration doesn't show up in your kitchen or your orbit around the sun. Gravity, electromagnetism, and the strong ties of matter dominate locally, but across the deserts between galaxies, on scales measured in tens or hundreds of millions of light years, the extra push becomes the rhythm of the dance. Does an accelerating universe end? In a sense, it ends communication. Over time, more galaxies slip past our event horizon. Their new light can never reach us. The night sky, trillions of years from now, would grow lonelier for any observers still around. That's not an age, it's a fading. The story doesn't stop, it becomes private. For us here and now, it's a reminder to savor what arrives. Each photon from a distant supernova, each line on a spectrum, each little clue that the cosmos keeps its own steady, surprising time. Dark energy is a placeholder name for something we see by its influence rather than by its glow. Picture space as elastic. If it carries a uniform energy, vacuum energy, then adding more space adds more push. As the universe grows, the gentle pressure remains like a soft breeze that never dies. The math of general relativity says such an energy acts with negative pressure, creating repulsion on cosmic scales. That fits the data for a simple, constant cosmological constant, but maybe the push evolves. Perhaps a slowly rolling field, quintessence, lounges in the background, changing its mood over eons. We test these possibilities by measuring the expansion curve in multiple ways. Supernovae, the imprint of sound waves frozen in galaxy clustering baryon acoustic oscillations, and the geometry encoded in the CMB. For now, the simplest story holds: a constant quiet pressure, small but relentless, dominating the universe's energy budget today. Does dark energy suggest an end? If it remains constant, expansion coasts into a polite, ever sparser future. Stars burn out, galaxies exhaust their gas, and the night deepens. Heat death, not with a bang but with a long sigh. If the push strengthens with time, space-time itself could tear bound structures apart in a far-off big rip. If it weakens, gravity might someday regain ground, though current evidence frowns at that. None of these are edges in the wall and fence sense. They're endings as moods, endings as tempos. Here's a softer image for sleep. You're on a raft, and the river widens. It doesn't throw you, it simply gives you more calm water around your little lantern. You can still read, still hum, still watch reflections. Dark energy is like that, an all-around hush that grows, not frightening, just spacious. Spin a galaxy and its outer stars should thinly orbit, slower with distance, like planets around the sun. Instead, many galaxies whirl with flat rotation curves, outer stars moving nearly as fast as inner ones. Something unseen deepens their gravity wells. Cluster galaxies, too, zip around too quickly to be bound by the luminous matter alone. Hot gas in clusters clings with help from extra gravity, and background galaxies are and smear in gravitational lensing patterns beyond what visible mass predicts. We call the missing mass dark matter. It doesn't shine or absorb, it mainly gravitates. Leading ideas picture it as a new kind of particle, slow-moving and cold on cosmic scales, that clumps into halos. Galaxies form within these halos like lanterns hung on an invisible scaffold. Computer simulations using cold, dark matter grow a cosmic web eerily similar to what we observe: filaments, nodes, voids, and grand walls stretching across hundreds of millions of light years. Could gravity itself be different? Modified gravity proposals attempt to explain some galactic behaviors without unseen matter, and they've taught us much. Yet on multiple fronts, lensing maps, the bullet-like collision of galaxy clusters separating gas from gravitational mass, the CMB's ripples, dark matter as an actual substance, continues to fit best. Does dark matter tell us whether space ends? Not really. It tells us how structure fills space, how the invisible architecture guides light and stars. It answers a different version of our question, not where does it stop, but what holds it together on the way. Tonight, imagine the night as a lace of hidden threads. You can't see the threads, only the dew where they intersect, galaxies sparkling on a web strung through the dark. The edges you worried about fade, the pattern quietly remains. On small scales, chaos, stars birthing, dying, colliding winds. On the grandest scales, order, a sponge-like network of filaments and nodes called a cosmic web. Galaxies rarely float alone. They gather along strands, stream into clusters, and leave behind vast, clean voids. This architecture arose from tiny initial ripples, those freckles in the CMB, amplified by gravity inside dark matter halos, while the universe expanded around them. We map the web with redshift surveys that record positions of millions of galaxies, turning the sky into a 3D lacework. We cross-check with weak gravitational lensing, subtle distortions of galaxy shapes by intervening mass. To weigh the filaments directly, we find baryon acoustic oscillations, frozen echoes of primordial sound waves, like a standard ruler imprinted in the galaxy distribution, helping measure the expansion history. Walk this web in your mind as you settle in, bright cities, clusters at the junctions, highways, filaments, connecting them, countryside, voids, quiet and sparse. It's not uniform, yet it's remarkably self-similar. Patterns repeat in spirit across scales. The web doesn't hint at an outer edge. It hints at process, how small differences become grand structure under simple rules and time. Does a web have a boundary? Only where threads stop being woven. In our universe, weaving continues as gas drizzles along filaments, fueling star formation, while mergers reshape the largest cities of galaxies. Far in the future, acceleration will thin the traffic between districts, but the local tapestry, the part you can walk, will still be there, stitched by gravity, lit by stars, and soft enough, even now, to lay your thoughts upon like a blanket. Light travels straight, unless space-time curves. Massive objects, dense space-time's geometry, and light, following the straightest available paths, geodesics, bends around those dents. That's gravitational lensing. A galaxy cluster can act like a natural telescope, magnifying and stretching background galaxies into arcs and multiple images. Even tiny mass clumps cause barely perceptible shears in galaxy shapes. Weak lensing, which when measured across millions of sources, maps the invisible mass between us and them. Lensing is a gift. It weighs what we can't touch, tests general relativity on huge scales, and turns clusters into observatories that peer deeper than our own. Time delays between multiple images, light taking different curved routes, become clocks that help refine the expansion rate. Sometimes lensing reveals what shouldn't be there, a dark halo with little starlight, a substructure hinting at the granular nature of dark matter. Edges, again. Lensing cares less about borders and more about paths. There's no frame to hit. There are only curves to follow. Imagine walking through hills at night with a lantern. The beams bend around slopes and shadows stretch. Do the hills have an edge? Perhaps miles away, but your experience is local. Step, glow, bend, repeat. The universe guides light similarly. No wall, just landscape. As you drift toward sleep, think of gravity putting on spectacles for you, sharpening some distant smudge into a lensed arc, a blue ribbon stretched by the weight of a cluster. Somewhere, photons left a young galaxy, were coaxed around a valley of mass, and continued to your eye, all so you could catch their story tonight and wonder softly how many more tales pass just beyond our noticing. Not all messages ride light. Colliding black holes and neutron stars send ripples, gravitational waves, through space-time itself, stretching and squeezing distances by less than a proton's width across kilometers of detector arms. LIGO and Virgo taught metal and laser light to hear that music. In 2015, we caught the first chirp, two black holes spiraling together 1 billion light-years away. Since then, a growing catalog, heavier, lighter, sometimes oddly paired. In 2017, 2 neutron stars collided, and we heard the waves and saw the light, a multi-messenger triumph that pinned down how gold and heavier elements are forged. Gravitational waves are clean historians. They barely interact with matter, so they carry crisp stories from violent places light may not escape. In the far future, a space-based detector, LISA, will listen for slower, deeper tones, supermassive black holes merging, white dwarfs humming, pulsar timing arrays now hint at a background baseline from giant black holes across cosmic history. Do such waves tell us where space ends? If anything, they say space is medium, not void, something that can ripple, carrying calm. Like throwing a pebble in a lake at night. Circles spread whether or not you see the shore. The lake's edge doesn't matter to the ripple, only the water does. Lie back and hear it this way. The universe can sing. Not loudly, not often, but sincerely. And in that music, there's no barrier, only quiet endurance. The way a lullaby can cross a room long after the singer has tiptoed out. Black holes are not holes. They're regions where gravity wins so thoroughly that even light cannot climb out. The event horizon is the not-quite edge, a boundary in time rather than a physical surface. Cross it inward, and all future paths point deeper. Stay outside, and with enough thrust, you can still turn away. Around spinning black holes, space-time drags like a whirlpool, and a hot, bright accretion disk lights the way in X-rays. We've imaged their silhouettes. The Event Horizon Telescope revealed a donut glow around the giant in M87 and at our own center square. Inside the horizon, the math predicts a singularity, curvature without limit, though quantum gravity will likely soften that. Outside, black holes act as cosmic sculptors, powering jets, shaping galaxies, stirring stars. They're not rare monsters, but standard citizens in massive systems. Do black holes prove space has sharp ends? Quite the opposite. The horizon is a one-way membrane defined by causality, a limit on where signals can go, not a wall you can touch and bounce off. It's a cousin to our cosmic event horizon. Both are about which futures remain connected to you. That's the universe's style of edge. Not a cliff, but a change in what can talk to what. As you drift, picture a shoreline at night you cannot see, only hear. Waves come, waves go, and somewhere beyond, there's a line where water returns to sea and not to you. You don't need to stand on that line to feel its meaning. The murmuring is enough, so it is with horizons. Soft-spoken boundaries drawn in time's ink, respected by light, understood best by listening. Stephen Hawking showed that black holes aren't perfectly black. Quantum fields near the horizon allow pairs of particles to wink into being. One falls in, the other escapes. To distant eyes, the black hole glows faintly, Hawking radiation, losing mass over unimaginable timescales. Tiny black holes would evaporate quickly. Supermassive ones will outlast stars. The idea turns the horizon from a silent absorber into a slow ember. But if black holes evaporate, what happens to the information about what fell in? Quantum theory dislikes destruction of information. The information paradox has driven decades of work and birthed a shimmering suggestion. Perhaps the bookkeeping lives on the horizon itself, encoded in subtle correlation. That line of thought feeds the holographic principle, the notion that a region's physics can be fully described by data on its boundary, much like a 3D scene stored on a 2D hologram. Holography doesn't mean the universe is a fake projection. It means that in some theories, volume and boundary carry equivalent stories. If true in broad strokes, then edges as ideas become even more interesting. The boundary might be where descriptions simplify, not where reality stops. How does this touch our bedtime question? It reframes end once more. Maybe the universe keeps trading borders for relations. What can talk to what? What can be encoded where? No curtains, only correspondences. Let that be your final thought tonight. Embers that whisper, horizons that remember, and a cosmos so careful with information that even disappearance becomes a conversation. If the universe feels smooth and coordinated across vast distances, it's because very early on it took a single astonishing breath. Inflation, the name we give to a split second of runaway expansion, stretched space faster than any rocket could ever dream, not by sending objects racing through the cosmos, but by enlarging the cosmos itself. Picture a tiny patch of the primordial universe, smaller than an atom, ballooning to astronomical size in a heartbeat. Wrinkles flattened, temperatures evened out. Causally connected regions, once neighbors, were pulled so far apart that today they sit beyond each other's horizons. Inflation, explains several riddles at once. Why is the cosmic microwave background so uniform? Because the regions we see on opposite sides of the sky were once close enough to swap heat before inflation separated them. Why is space so close to flat? Because inflating any curved surface tends to iron the curvature away, like blowing up a balloon until any local lumpiness looks smooth. Why do we have the tiny seed fluctuations that became galaxies? Because quantum jitters, microscopic waves and fields were stretched to cosmic scales, freezing into the faint mottling we observe in the CMB. Does inflation tell us whether space ends? It suggests the opposite, a tendency toward more. Some versions even predict eternal inflation, where pockets of space stop inflating at different times, budding off bubble universes with their own properties, an enormous, perhaps endless quilt. But even without that speculative flourish, inflation replaces the idea of an outer wall with something subtler, beginnings shaped by dynamics, not boundaries. What looks like emptiness is the memory of a smoothing, the hush after a powerful exhale. Let that image settle you. The universe once caught its breath, and we are living in the calm that followed. Even if space is nearly flat, it might still fold back on itself in clever ways. Imagine living in a three-dimensional room whose opposite walls are connected. Walk straight through one side, and you re-enter from the other. No edges, just wrap around. Mathematicians call this a non-trivial topology. One common example is the 3 torus, a 3D analog of a donut surface. In such a universe, light could circumnavigate and show us ghostly copies of distant structures from multiple directions. How would we know? One test looks for matched circles in the cosmic microwave background. Identical rings of temperature patterns appearing at different spots on the sky where the last scattering surface overlaps itself. Satellite maps from WMAP and Planck have searched for these signatures and so far found none at detectable sizes. That doesn't kill the idea. Space could be larger than our observable patch, looping on scales beyond our reach, but it nudges us toward the simplest picture, vast, and to our instruments, non-repeating. We also test topology with galaxy surveys, hunting for repeating constellations of clusters or patterns inconsistent with simple infinity. Again, the sky stays shy. If space loops, it hides the trick outside our light bubble. Does a looped universe end? Not at all. It would be finite in volume yet unbounded. No walls, just continuity. Like walking the earth and returning to your start without finding an edge. Whether the cosmos is infinite or a subtle loop, the feeling to carry into sleep is the same. There's no cliff in the dark, only continuity. If there are repeats, they're too far to haunt us. If there aren't, the sky is roomy enough to cradle every question you brought to bed. Between filaments of galaxies lie the great voids, enormous. Under dense regions, tens to hundreds of millions of light years across. They are not absolute nothingness. They hold thin gas, a scattering of faint dwarfs, and the whisper of dark matter. But compared to the bustling clusters at the web's nodes, voids are spacious reading rooms of the cosmos, long tables with a single lamp. Voids form as gravity shepherds matter toward filaments and clusters, leaving behind low-density basins that expand a bit faster than average. Their boundaries sharpen over time. Their interiors grow calmer. We map them by charting where galaxies are not, by watching how their emptiness lenses background light ever so slightly, and by measuring how galaxy flows stream around them. Do voids hint at an edge to space? They tease the intuition so much emptiness in one place must be near a boundary, but voids are interior shapes, not borders. Bubbles in rising bread, pockets inside the loaf. They sit wholly within the universe, sculpted by the same rules that build the crowded parts. Even a perfectly infinite cosmos would host voids. Even a looping finite one would have plenty. Emptiness is part of structure, not the lack of it. If you need an image to rest on, picture a nighttime city seen from above. Streets bright with traffic-marked filaments, parks and lakes lie dark and broad between. The city doesn't end at the park, it breathes. Because the park exists, room for quiet, room for stars to gather at the edge of the path, the cosmos breathes this way too. Tonight, lay your thoughts in a void for a while. Let the quiet do what quiet does best, hold you without edges. A favorite cosmic puzzle. Distant galaxies recede from us faster than light. Is that allowed? Yes, because nothing local is outrunning the photon. What speeds past light is the increase of distance itself in an expanding universe. Relativity forbids objects moving through space faster than light, not space increasing the separation between coming points. Two clocks help sort the language. Peculiar velocity is motion through space. Stars orbiting, galaxies buzzing within a cluster, capped by light speed. Recession velocity is the Hubble flow, how distance grows between far-flung galaxies as the scale factor increases, unbounded at large separations. Stitch those together and you get the curious truth. A galaxy can sit still in its local patch, yet recede superluminally from us, because there's so much between being created each second. This distinction also clarifies horizons. Light emitted by a very distant galaxy may never reach us if the intervening space grows too quickly. Other beams sent earlier when we were closer do arrive. That's why we can see some galaxies that are, right now, beyond the speed of light recession boundary. We're catching their older photons that slipped out before the river ran too fast. Is there an edge implied by superluminal recession? No, only a limit on communication, on what can exchange signals with us now or in the future. Think of an escalator that accelerates as you climb. The steps beneath your feet are gentle, workable. Far away, the staircase speeds beyond your stride. There's no wall at the top, just an unreachable region. The universe is kind like that. It lets you keep your balance where you are, and it keeps its grand stretch respectful, even as distances grow beyond any sprint. Relativity organizes events with light cones. Imagine a flashlight in space-time. The past light cone holds everything that could have influenced you, all signals that had time to arrive since your beginning. The future light cone contains everything you can still affect, all places your signals can reach given cosmic expansion. These cones are personal. Shift your place or time, and the cones tilt and widen. Cosmic horizons are built from these cones. The particle horizon is the edge of your past light cone back to the Big Bang, how far the oldest messages had time to travel. The event horizon is the boundary of your future light cone regions whose new light will never reach you because expansion wins the race forever. There's also an apparent horizon tied to the expansion rate right now, and a Hubble radius where recession reaches light speed. Different edges for different questions. None are walls, all are limits on conversation. The beauty of light cones is how they localize the infinite. You live inside a manageable bubble of causality. The rest of the universe exists, but its gossip can't always find you. That's not a loss. It is a permission structure for calm. You don't need every photon to validate your night. Visualize it gently. You stand beneath a street lamp in a slow snowfall. The flakes you can catch are your past. The ones you toss into the air are your future. Beyond the pool of light, the snow keeps falling, indifferent to your circle, yet perfectly content to let it be. Space ends nowhere in that scene, and still your world has a boundary, the place where light grows thin and your breath shows. Long after the cosmic microwave background set light free, the universe slipped into a long, dark age, gas-cooled. No stars yet burned, gravity worked quietly, drawing matter into halos. Then, a first generation of stars, massive, short-lived, bright as revelations, ignited. Their ultraviolet glow, joined by early galaxies and black hole accretion, began to tear electrons from hydrogen atoms, reionizing the cosmos. The fog lifted a second time. We call this the epoch of reionization, a gradual brightening that likely unfolded between redshifts 6 to 10 hundreds of millions of years after the beginning. We glimpse it by watching how distant galaxies' light is absorbed by intervening gas, and soon by mapping the faint 21-centimeter radio whisper of neutral hydrogen as it surrenders to starlight. Telescopes like JWST peer into this transition, catching galaxies when they were toddlers, dusty, busy, underslept. Was reionization an edge? It was an era, not a wall. A change in transparency, a new rulebook for how light travels. The universe didn't gain borders, it lost a veil. That rhythm, fog, clear, runs softly underneath our bigger question. Over and over, the cosmos swaps limits of a certain kind, what's visible, what's coupled, without ever erecting a fence around itself. If you need a bedtime picture, try this: a shoreline at dawn. First comes the gray outline, then the soft pastel of houses, then the bright glints on windows as the sun lifts higher. Nothing new was built in those minutes. Only clarity arrived. The sea did not end at any point, it merely revealed itself. So too with the early universe. So too, perhaps, with your own thoughts as they clear enough to sleep. We live in the local group, a small archipelago of galaxies dominated by the Milky Way and Andromeda, bound together inside a common dark matter halo. In about 4 billion years, those two grand spirals will drift into one another and merge, their stars mostly sailing past without collision while gas compresses, sparks, and settles. The result? A single, mellow giant, sometimes nicknamed Milk, because cosmic expansion is accelerating. Unbound galaxies outside our local supercluster neighborhood will continue to slip beyond our event horizon. In a few 100 billion years, only the gravitationally bound island, our merged remnant, and its companions will remain visible to far future astronomers. The CMB will redshift beyond detectability. The Hubble flow will fade from local sight to those future minds. The universe may look small, old, and static. Is that the end of space? No, just the end of a conversation with the wider sea. Our island doesn't shatter when the tide goes out, it grows private. Stars will still be born for a while, planets will still turn, and the night will still be a dome worth wandering under. The practical horizon will tighten, but the true landscape will remain as broad as ever, simply uninterested in sending postcards. Let that distant prospect soothe you rather than sadden the knowledge that meaning is possible on any scale. Whether you stand in a city of galaxies or a single quiet port, you can look up, count, measure, and tell stories. Space ends nowhere in that future, and yet every home will feel more intimately bounded. It's a reminder tucked into tonight. You don't need the whole sky to feel the sky. Cosmic fate is a menu with a few familiar courses. With a cosmological constant, the simplest, dark energy. The expansion coasts forever. Matter thins, star formation dwindles, long-lived red dwarfs flicker for trillions of years, white dwarfs cool to black. Black holes slowly evaporate. Entry wins not with drama, but with dilution. A long evening called heat death, where meaningful temperature differences fade. If dark energy strengthens with time, distances grow so fast that eventually even galaxy clusters, then galaxies, then solar systems, and finally atoms would be torn apart. The big rip, a crescendo ending in silence. Current data doesn't demand this, but it doesn't perfectly forbid it either. We watch and refine. If dark energy weakens or flips side, unlikely by today's lights, gravity could halt and reverse expansion, leading to a big crunch. Some ideas imagine a bounce, a new expansion budding from the collapse, making the universe cyclic. Other speculative models paint gentler handoffs, vacuum decay bubbles, conformal rescaling, metaphors stacked on equations. None of these fates involve hitting an outer wall. They are endings as thermodynamics, endings as geometry, how clocks behave, how gradients fade, how paths converge. Picture 3 lullabies. In the first, the song grows softer until you hear only breath. In the second, the tempo accelerates until the notes tear and scatter. In the third, the cadence slows to a stop, and then perhaps begins again on a new key. Different music, same stage, space-time without a curtain. Whichever score the cosmos follows, your part is now. You listen, you measure, you wonder. That is already enough. Meaning for one lifetime, and more than enough to carry you gently into sleep. At very small scales, Planck length Aristi of 1.6 guide 10 by 10 Planck time, Rio 5.4 guide 10 by 10.10 by 10 cents. Our best theories jostle. General relativity treats space-time as smooth and continuous. Quantum mechanics demands uncertainty and discreteness in how fields behave. Push both to the limit and the math protests. We need a quantum theory of gravity to describe those first flickers after the beginning and the hearts of black holes. Candidates abound. Loop quantum gravity with its spin networks, string theory with vibrating extended objects and extra dimensions, asymptotic safety, causal sets, emergent space-time from entanglement. Each offers glimpses, area quantization hints, holographic dualities, black hole microstate counting. None has yet marched from elegant proposal to decisive, unique prediction confirmed by experiment. That's okay. Foundational physics often advances by decades of gentle pressure. Is the Planck scale an edge? It's a boundary of current description, not of reality. Like the resolution limit of a camera, the scene continues beyond the pixels. Only your sharpness failed. We may never build colliders that reach such energies, but the universe is generous with natural laboratories. Black holes, the CMB, primordial gravitational waves that could imprint signatures of Planck-era physics in measurables we can touch. For rest, hold this thought. It's fine to sleep before you've solved everything. The cosmos itself took hundreds of millions of years to turn on its first stars. Your curiosity can be patient too. The frontier is not a cliff, it's a foggy meadow at dawn where shapes are real but soft. You'll see farther after you've closed your eyes for a while. Edges comfort us. Rooms have walls, days have midnights, stories have last pages. An end of space would be tidy, a cosmic cover to close. But the universe prefers continuity, horizons instead of fences, phases instead of doors, correspondences instead of cutoffs. When we ask, does space end? We're often asking for reassurance that reality is a container like the ones we know. The answer we get back is kinder. Reality is a relationship. Distances grow, not because something pushes from outside, but because the inside evolves. Visibility fades not because a curtain drops, but because signals lose their race. Finite and unbounded is an option, infinite and gently curved is another. In each movement replaces border, dynamics replace edge. That can feel unsettling until you live with it for a while. Then it begins to feel like freedom. You don't need a last streetlight to find your way home. You need a path and the memory of where you've been. Cosmology gives you both. a map of how light travels, and a story of how structure formed. It withholds the final frame, and in doing so, invites you to keep looking up. So here's your closing image for tonight's chapter. A shoreline at night, tide breathing, stars, steady, no fences, only horizon. The sea doesn't end where your sight does. It continues, serenely indifferent, serenely welcoming. Space is that sea. Your questions are its waves. Let them come and go. The beach will still be there in the morning, and so will the sky. Gravity doesn't just tug on planets, it bends the very paths of light. When a massive object, like a galaxy cluster, sits between us and something farther away, space-time curves and background light arcs around it. We call this gravitational lensing. Sometimes it smears a distant galaxy into stretched streaks. Sometimes it duplicates it into multiple images. Sometimes in a nearly perfect alignment, it draws a bright halo called an Einstein ring. It's dramatic, but what it isn't is an edge. Lensing is the universe showing its flexibility, not its perimeter. There are two flavors to keep in mind. Strong lensing makes those bold arcs and multiple images, the kind you'll spot in telescope posters. Weak lensing is subtler, tiny, coherent distortions of many background galaxies that, when statistically stacked, reveal how mass is distributed on cosmic scales. With weak lensing, we can map invisible scaffolding, dark matter webs that hold galaxies in place. This bending does more than delight our eyes. Lensing lets us weigh clusters, test gravity, magnify ultra-distant galaxies we'd never see otherwise, and cross-check the contents of the cosmos against other probes. Each distorted image is a measurement. Each measurement is one more stitch in the map. If you need a gentle picture for sleep, imagine moonlight passing through ripples on a lake, turning straight beams into trembling ribbons. The ripples aren't walls, they're textures, carrying stories about the wind. Gravitational lensing works like that. Space doesn't stop where light curves. It merely reveals where mass is hiding. The more we watch light bend, the more we learn how to trust the road ahead. No cliffs, only contours, no fences, only the graceful grammar of geometry guiding photons home. Distances in the universe aren't measured with a single ruler, they're stitched together from many. Closer to home, we use parallax. Watch a nearby star shift against the background as Earth orbits the Sun, a cosmic triangulation. Farther out, we rely on standard candles, objects whose intrinsic brightness we understand well enough to infer distance from apparent dimness. Cepheid variable stars pulse with a period tied to their true luminosity. Type YA's supernovae, stellar explosions with near-uniform peak brightness, carry that ladder into deep space. Beyond candles, we use standard rulers, fixed-size ripples, frozen in the distribution of galaxies. You'll meet them in next part. And we fit the entire expansion history with redshift distance relationships from many probes combined. Each rung overlaps the next, cross-checking and correcting. Errors shrink not by faith in one tool, but by conversation among many.
Why all this work? Because distance is the keystone of cosmology. Without it, a dim galaxy could be either nearby and small or far and grand. With it, redshift turns from color to clock. Brightness becomes history. The map goes from a flat star chart to a living layered atlas.
No edge appears when we extend the ladder, only more sky. The ladder doesn't lean on a wall. It stands in open air, steady, because its rungs are interlocked. Think of it as a bedtime craft project. Measure, overlap, tie, and test. The more knots you add, the stronger the net becomes. Then you can lie back on it and rest, knowing the distances beneath you are held not by one promise, but by many hands. In the hot early universe, photons and baryons, ordinary matter, sloshed together like sound waves in a tightly coupled fluid, Where gravity tried to pull matter in, radiation pushed back out, sending spherical pressure waves racing across space. When the cosmos cooled enough for light to decouple, those waves froze, leaving a subtle preferred separation imprinted in matter. Galaxies today are slightly more likely to be found about 500 million light-years apart in moving terms than at nearby separations. These are baryon acoustic oscillations, BAO for short. BAO act as a standard ruler. Measure how big that ripple appears at different redshifts, and you can infer how the scale of the universe has grown. Survey after survey, mapping millions of galaxies, reads this ruler in multiple epochs, letting us trace the expansion history without assuming much else. Pair BAO with supernovae and the cosmic microwave background, and a coherent story emerges, a flattish geometry, a cosmos dominated today by dark energy, and an expansion that has been accelerating for the last few billion years. A ruler implies measuring, not fencing. BAO don't outline an edge, they calibrate the vast interior. Think of ripples on a pond after a single pebble drops. The wavefronts expand, then freeze into a faint pattern on the surface. Later you can examine the spacing of those rings to estimate properties of the pond, even if the original splash is long gone. The universe kept its own faint rings, and we learned to read them. As you drift towards sleep, picture those quiet ancient waves. A hush of sound in light, a whisper that became a ruler that became confidence, not in where the cosmos stops, but in how softly and steadily it grows. Galaxies spin too quickly at their edges for the stars we see to be all that's holding them together. The outer stars should fly off, unless an unseen mass deepens the gravitational clusters too, way more than their luminous parts suggest. Their galaxies whiz inside potential wells too deep to be explained by visible matter alone. Gravitational lensing maps the same conclusion. Mass is there, bending light, even where starlight is thin. The cosmic microwave background, with its precise ripples, demands a non-luminous component to fit the pattern. Different lines of evidence, one chorus. Most matter is dark. What is it? Not atoms, not photons, not the stuff of us. Candidates range from weakly interacting particles to axions to even more exotic ideas. We search with underground detectors, colliders, and sky. Meanwhile, dark matter behaves simply on large scales. It clusters, it pulls, it seeds the web on which galaxies form like dew on a spider's threads. Dark matter doesn't hint at an outer boundary. It's a content story, not a contour. It tells us what fills the universe, not where the universe ends. Adding dark matter to the map is like dimming the room and suddenly seeing the scaffolding behind a stage. The performance never had walls. It had structure you hadn't noticed. For a calming image, picture lanterns hung along a barely visible bridge on a foggy night. The lights are the galaxies. The bridge cables are the dark matter. You can't see the cables directly, but the pattern of lights betrays their tension. The bridge doesn't dead end in the mist. It continues trustworthy because its unseen strands hold. By the late 1990s, two teams using Type I supernovae as standard candles found something startling. Distant supernovae look dimmer than expected in a merely coasting universe. The interpretation that best fits many datasets is simple and strange. Cosmic expansion is accelerating. Whatever is driving it, we call dark energy. The simplest model is a cosmological constant, energy inherent to empty space, with an unchanging density and a pressure that pulls with negative sign on the expansion equations. Other possibilities include slowly rolling fields or more radical tweaks to gravity on enormous scales. Observations of supernovae, BAO, weak lensing, galaxy clusters, and the cosmic microwave background weave together to constrain this equation of state. So far, the cosmological constant fits well: quiet, ubiquitous, stubborn. Dark energy changes futures, not floor plans. It doesn't put a wall at the edge. It turns the dimmer on the universe's conversation. More and more distant galaxies will drift beyond our event horizon. Fewer new messages will arrive. Locally, gravity keeps families together. The Milky Way and Andromeda will still merge. Stars will still rise and fade. The acceleration is a mood, not a barricade. For rest, imagine a ballroom where dancers at the edges glide outward on a gently speeding conveyor, while pairs in the center keep waltzing, bound by their embrace. The room hasn't grown walls. The space between distant dancers simply increases faster. Dark energy is the hymn of that floor, subtle, relentless, and for now, the best explanation for why the far lights are dimmer than our first guesses said they'd be. Light's wavelength stretches with the fabric, turning blue to red, note to lower note, clock to slower clock. Different questions ask for different distances: luminosity distance for brightness, angular diameter distance for apparent size, co-moving distance for mapping large-scale structure, look-back time for how long has that photon been traveling. None of these are edges. They're translations between what we observe and what we want to know. Think of riding an escalator with a tape measure. If you measure steps in step units, the number between two marks never changes co-moving. If you measure in centimeters, the distance grows as the escalator stretches proper. Neither method invents a wall at the top. They merely keep track of motion in the way most useful to your task. As you unwind for sleep, let the jargon drift away and keep the feeling the universe gives you multiple consistent languages to describe far. When one feels confusing, another clarifies. It's like switching from listening to a song's melody to following its rhythm. The tune remains the same, and no matter how you count, the music ends in the same gentle place. More space, not less fence. It's tempting to ask, where's the center of the expansion? But in a homogeneous, isotropic universe, every point sees every other point recede. On average, there is no special origin in space, only a common origin in time. What we do have is a practical rest frame, the cosmic microwave background, CMB. If we move relative to that ancient light, it looks slightly warmer in the direction we're heading and cooler behind, like walking into a breeze. This dipole tells us our local group speeds through space at a few hundred kilometers relative to the CMB. The CMB frame isn't a cosmic throne. It's a convenient way to say, here's where the afterglow is most balanced. Shift to that frame, and much of the sky's asymmetry smooths out. But it doesn't reveal a center. It reveals a calm. Picture yourself floating in a gently expanding loaf of raisin bread. From your raisin, all others recede, and the dough swells evenly. Move a bit, and you'll feel a breeze of raisins drifting past in the opposite direction. That's the dipole. Switch to the frame drifting with the dough, and the breeze stops. Still no special raisin, no privileged spot, only a choice of coordinates that lets you rest. Let that be your bedtime coordinate change. Trade the busy frame for the calm one. The universe won't mind. It has no favorite seat. Wherever you are, the story reads the same. Expansion everywhere, edges nowhere, and a background glow that sets the room's temperature without picking a centerpiece. If the universe were eternal, static, and infinite, with stars uniformly filling space, the night sky should blaze as bright as the surface of a star in every direction. It doesn't. The resolution, Olber's paradox, untangled, comes from endings that aren't edges. First, the universe has a finite age. Distant light hasn't had time to reach us from arbitrarily far away. Second, the cosmos expands as light travels, its energy stretches to longer wavelengths, dimming the background. Third, stars and galaxies aren't everywhere at the same density forever. They form, evolve, and sometimes hide behind. The combined effect leaves the night exquisitely dark, punctuated by points and smudges, the nearest and brightest beacons, and a faint microwave glow if you tune your instruments right. Darkness, then, is not a symptom of boundaries. It's a fingerprint of history and motion. Think of a city at night with a curfew and fog. Not every window is lit, and distant lights lose their sting. The street doesn't end where the glow fades. It continues into calm neighborhoods where people are sleeping. Let that image tuck you in. The universe is restful on purpose. Your eyes get darkness because the cosmos is young enough and growing enough to spare them, and inside that quiet a few lights remain for company, close, kind, and human-scaled reminders that even without an edge, there is always a place to rest your gaze. A supernova in a distant galaxy doesn't just look redder, its light curve unfolds more slowly by a factor of tons. That's cosmic time dilation. When the universe was smaller by that factor, intervals of light were compressed. As those intervals traverse expanding space, they stretch, seconds become longer, beats slow down. Distant quasars flare in slow motion, gamma-ray bursts linger longer in high hours. The cosmos changes not only what you see, but how quickly you see it happen. Time dilation is a comfort, not a cut. It means the same physical event, performed on a smaller stage, reaches you as a lullaby, not a shout. The universe respects the speed limit of light and the rhythm set by expansion, then hands you a softened performance filtered by distance and time. Imagine hearing a favorite song from a party across a park. The notes arrive lower and slower, pulled thin by wind and space. The song doesn't stop at the edge of the lawn. It travels, patient and altered. Astronomy listens like that. We read stretched rhythms, decode them, and recover the original tempo. In doing so, we trade edges for empathy, the recognition that what's far away is still familiar, just playing through a larger room. As you breathe out and in, think of your chest as a tiny scale factor. Rise and fall, expand and rest. The universe keeps the big version. You keep the small. Both are clocks. Both are on it. When massive objects dance, black holes merging, neutron stars colliding, they send ripples through space-time itself. Gravitational waves. These waves don't need a medium. They are changes in the metric, traveling at light speed, passing through matter with barely a nod. Detectors on Earth have felt these whispers as tiny stretches and squeezes, smaller than a proton across kilometers of laser arms. Each chirp is a story, masses weighed, spins inferred, distances gauged without candles or rulers. Gravitational waves give us another way to map the cosmos. Standard sirens, mergers with an electromagnetic counterpart, can calibrate expansion directly. A future background hum, the stochastic murmur of countless distant mergers, and perhaps primordial waves from the universe's first instance, would become a new kind of sky, not of light, but of rhythm. Do waves reveal an edge? No, their virtue is that they ignore obstacles. They slip past dust that blocks starlight, past gas that muddles spectra. If there were a wall, they'd feel it least of all. Their existence is another reminder that the universe is connected by rules, not enclosed by railings. Drift off with this, a pond at night, so still that the stars reflect somewhere far across. A fish turns, sending faint rings outward. They reach your shore long after the motion that made them. You never see the fish, but the water tells the truth. A movement happened. The world responded. Space is that pond, and you are listening well. No edges, only ripples, arriving, passing, and leaving the surface a little more understood than before. On the largest scales, matter doesn't spread evenly like sugar on a table. It gathers into a foam-like architecture, the cosmic web, thin filaments of galaxies threading together into nodes called clusters, with vast, peaceful voids between. Sculpts this pattern. Over billions of years, dark matter collapses first, forming invisible scaffolding. Gas follows the contours, cools, ignites stars, and lights the filaments. Like dew outlining the spider's threads at dawn, galaxies trace lines you'd otherwise miss. Voids aren't empty, just underdense. They hold wisps of gas, a sprinkling of dwarf galaxies, and the faint pull of the same physics. Their stillness is valuable. Light crossing the void suffers fewer interruptions from dust and gas. Surveys use these serene expanses to test cosmic expansion and the growth of structure. Filaments, meanwhile, are the highways along which galaxies travel and merge, feeding clusters and shaping galaxy evolution. This pattern doesn't hint at a wall. Instead, it shows continuity with texture, denser here, gentler there, but connected everywhere. If you could drift through the web, you'd feel a rhythmic alternation, busy boulevards of clusters, then quiet neighborhoods of voids, no cul-de-sacs, only transitions. For sleep, picture a lacework of faint, glowing threads stretched across a dim room. Between the threads, soft pockets of calm, along them, tiny ornaments, galaxies hung at crossings. The lace doesn't end at its edges, it simply becomes too fine to see. That's our map of out there, not a fence, but a fabric. Galaxies are not static postcards, they're ecosystems. Early on, gas falls in along filaments, cools and condenses into bright blue star-forming disks. Over time, galaxies meet and merge, sometimes gently, sometimes like surf colliding with rocks. These encounters scramble orbits, thicken disks into spheroids, funnel gas to central starbursts, and awaken supermassive black holes that blaze as quasars. Eventually, many galaxies quench, their star-making slows as gas is heated, blown out, or simply used up. Some become serene ellipticals, red, smooth, and old, residing in clusters where fresh fuel is scarce. Others keep a trickle of star birth going in their spiral arms, fed by minor mergers or recycled gas. This life cycle doesn't suggest a boundary to space. It's a story about time and environment. Everywhere the web provides gas, galaxies thrive. Where the pantry empties, mergers tell us the universe is social on grand scales. Orbits intersect, halos overlap, and structures cohere without any stage edge calling curtain.
If you need a bedtime image,
Think of cities. Young districts buzz construction cranes, new lights, loud music, older quarters, quiet libraries, warm windows, soft voices, roads connect them, people move, neighborhoods change. The city doesn't end because one street calms. It continues, block after block, style after style, history folding into the present. Galaxies grow up like that. Busy to gentle, blue to gold, under one big sky. In astronomy, metals means everything heavier than helium. The first stars formed from pristine hydrogen and helium, forged in the big. Inside their cores, they cooked new elements, carbon for life's scaffolding, oxygen for breath, iron for future planets, and flung them outward in winds and supernovae. Each generation enriched the gas a little more, enabling cooler clouds, smaller stars, rocky worlds, and complex chemistry. We track this enrichment with spectra. Dark absorption lines reveal which elements sit between us and a star. Emission lines from glowing gas encode temperatures, densities, and metallicities. Across cosmic time, we see a gradual rise in metals, Galaxies today are more enriched than their ancestors. Cluster gas bears the fingerprints of countless supernovae. Even the thin circumgalactic medium carries heavy elements in a tenuous halo. This elemental bookkeeping doesn't plot an end to space. It chronicles a deepening story. Where matter gathers, stars write new chapters in periodic table ink. Where space thins, the writing fades but doesn't stop. The universe is a recycling program on an epic schedule, not a warehouse with a back wall. For a soothing metaphor, picture a long table where cooks pass down recipes. Early dishes are simple, few ingredients, bold heat. Later spices arrive, flavors combine. The menu widens. The dining hall doesn't conclude when the cuisine grows subtle. It feels larger because each plate remembers the last. You are, quite literally, made of those recipes, stardust reassembled, thinking about the kitchen that never needed walls. After recombination, the universe entered a long, dark age. Neutral hydrogen filled space. There were no stars yet, only the slow growth of structure in the dark. Then, as the first stars and galaxies flickered on, their energetic photons began to break hydrogen atoms apart, ionizing the fog. Pockets of transparency grew around these new lights, expanded, overlapped, and eventually transformed the cosmos from opaque to clear. This era is cosmic reionization, the sunrise after the longest night. We hunt its timeline with several tools: the spectra of very distant quasars, where a deep trough, the Gunn-Peterson effect, signals lingering neutral gas, the small-scale imprint of free electrons on the cosmic microwave background, and now radio experiments tuning to the 21-centimeter whisper of hydrogen, hoping to map bubbles of ionization blooming across space. Reionization marks a change of state, not a perimeter. It's weather, not geography, an atmospheric clearing that let light travel freely. The expanding sea of transparency didn't stop at a shore. It filled the basin wherever stars and black holes lit the match. To drift towards sleep, imagine lanterns scattered across a foggy valley. Each lamp burns a clearing in the mist. Circles widen, meet, and merge until the whole valley is visible. The hillside never had a fence. It only had a fog that lifted. Our view of the early universe arrived the same way. Lamplight first, daylight later, revealing a landscape that was always there. Before the universe was a second old, neutrinos, near massless, weakly interacting particles decoupled from matter and radiation, slipping free to stream almost unhindered ever since. Today, this cosmic neutrino background drifts through us by the billions each second, colder than the microwave background, nearly impossible to catch. We infer its presence from its gravitational fingerprints, how it tweaks the expansion rate, smooths small-scale structure, and nudges the cosmic microwave background's ripples. Neutrinos remind us that the cosmos is full of quiet traffic. Photons, gravitons, neutrinos all carry history without needing a road or a wall. If space had an edge, these messengers would be the first to whisper about it. Instead, they whisper about continuity and early heat, about a time when the universe was dense enough to set every future rhythm in place. For a calming image, think of a silent breeze passing through lace curtains. You don't see the air, but the pattern trembles. Cosmology reads those tremors in sky maps and power spectra, reconstructing a wind you cannot feel. The lesson is gentle and consistent. Even what barely touches us participates in the whole. The room is larger than our senses, and yet the rules are simple enough to sleep on. We only get one observable universe, one sky to sample. Even if our instruments were perfect, some questions have an irreducible uncertainty because we can't re-roll the cosmic dice. That statistical floor is cosmic variance. Measure the largest ripples in the microwave background, You're limited by the fact there are only so many distinct horizon-scale patches to count. Survey the biggest structures. You can't observe them from a dozen vantage points. You live in one. Cosmic variance isn't a flaw. It's a boundary of knowledge, different from an edge in space. It tells us that some parameters will always have a soft halo of uncertainty. We reduce it by looking at smaller scales, more samples, by combining many kinds of evidence, and by building deeper surveys, but the largest modes remain few. The cosmos is big, but your sample is finite. Let that be a mercy at bedtime. Not every question needs a sharp decimal. Some answers are honest ranges stitched from the best we can do. The sky is a conversation with occasional static, not a courtroom transcript. Knowing the difference keeps us humble and, paradoxically, more certain of what we do know. No wall, just a gentle blur at the edges of statistics. Even if space is nearly flat, it could still wrap around in clever ways. Topology is the study of those global properties, how space might connect to itself beyond our sight. In a multiply-connected universe, a beam of light could, in principle, circumnavigate and re-enter from another direction. One proposed test: search the cosmic microwave background for matched circles, repeated patterns from the same patch of last scattering light arriving along different paths. So far, sky maps haven't revealed convincing, large-scale repeats that nudges us toward a space larger than our observable patch, or a topology whose signatures lie beyond current sensitivity. Either way, the takeaway is soothing. If space loops, the loop is wide. If it doesn't, the view is open. Both are continuous. Neither needs a cliff. Imagine walking a vast, dimly lit hallway. If it's a loop, your footsteps will eventually bring you past the same painting. If it's straight, you'll see new frames forever. For now, our lantern hasn't found repetitions within the distance we can walk. The hallway remains mysterious and pleasant, echoing softly with possibilities. Event horizon means different things in different arenas. Around a black hole, it's a one-way surface. Cross it, and no light or signal ever returns. It's a local boundary sculpted by extreme curvature. In cosmology, an event horizon is global, the farthest distance from which light emitted now can ever reach us, given accelerating expansion. Objects beyond that cosmological horizon aren't trapped by a hole. They're simply receding in such a way that their new messages can't overtake the swelling space between. One horizon is a gate. The other is a garden growing faster than a runner. Neither implies an edge to space itself. Black holes punctuate space-time with private regions. The cosmic horizon describes our future light-receiving limit. You can orbit a black hole from afar and trade signals. You can also see a galaxy today that has already slipped beyond our future reach, receiving only its older light. Think of two kinds of silence. One is a closed door in a quiet house. The other is distance across a widening field. Both feel hushed, but for different reasons. Understanding which silence you're hearing makes the world less frightening and sleep closer at hand. If dark energy behaves like a cosmological constant, expansion keeps accelerating. In trillions of years, unbound galaxies drift past our event horizon. The night sky for far future astronomers will hold only their local group merged into a single giant galaxy. Star formation dwindles as gas is locked in remnants. Red dwarfs burn for eons, then cool, white dwarfs fade to black. Proton decay, if it happens, and black hole evaporation, if permitted by quantum rules, carry the last embers away. The universe relaxes toward a thin, cold bath of low-energy quanta heat. This forecast is somber but not bleak. It's the ultimate consequence of the same rules that made stars and you. Energy conserved, entropy counting states, space-time honoring causal limits. Nowhere in this script is a wall. There's only time and thinning fuel. The party doesn't end with a slammed door. It drifts to a gentle close, chairs emptying, music turning to a hum. As you settle, imagine a beach at dusk. People depart, the air cools, the tide evens the footprints. The ocean remains broad, calm, and continuous. The cosmos behaves like that on a scale beyond scales. It won't stop being space, it will simply grow quiet. In an expanding universe, photons lose energy as their wavelengths stretch cosmological redshift. It's natural to ask, where did that energy go? In general relativity, global energy conservation is subtle. Space-time curvature means there's no single, universal notion of total energy for the whole universe. Locally, on scales where space-time looks flat, energy momentum is conserved with exquisite precision. Globally, the redshift isn't paying a bill to some reservoir, it's a feature of geometry. As the scale factor grows, the energy density in radiation scales away. Dark energy further challenges our everyday intuition. Vacuum energy can remain roughly constant per unit volume even as volume increases, so the total vacuum energy within a co-moving region grows. That sounds like free lunch, but the menu is the Einstein field equations themselves. Geometry and energy are interwoven. You can't change one without changing the other. No edge is required for this accounting to balance. The rules are local and relational, not dependent on a box with walls. Think of a stretchy fabric patterned with musical notes. Stretch the cloth and the note spacing widens. The pitch drops, no one stole a sound, the instrument changed shape. Breathe out. The universe runs on consistent rules, even when they outpace our metaphors. That consistency, not a boundary, is what lets us sleep. Distances in an expanding universe are trickier than road miles. If you freeze the cosmic movie right now and stretch a tape measure between us and a distant galaxy, that instant separation is the proper distance. But because space keeps growing, cosmologists prefer a ruler that expands with the fabric itself, co-moving distance. Think of co-moving coordinates as dots painted on a rising loaf. Each dot's label never changes, even as the dough swells between them. Why juggle two notions? Because different questions need different rulers. Light's journey cares about the whole history of expansion. Co-moving distances conveniently track positions factored out by growth. Proper distance tells you how far today, while co-moving distance remembers where on the grid regardless of size. Add in luminosity distance, how faint things appear, and angular diameter distance, how big they look, and you get a toolkit tuned to the universe's changing scale. Imagine walking on an airport moving walkway. Your steps are your own speed, peculiar motion. The walkway's drift is expansion. If you ask, how far am I from gate 42 right now? That's like proper distance. If you ask, where am I in walkway tiles? That's comb. Neither implies a wall at the end of the terminal. They simply help you navigate a space that's in motion. For sleep, picture mile markers sliding gently apart as the landscape breathes. You're not lost. The map just stretches with you. In a cosmos without edges, the smartest trick is choosing the right ruler for the moment and letting the rest glide by like scenery on a calm, ever-lengthening road. How do we weigh and measure the universe? With a stack of cross-check tools. Nearby, we calibrate distances using parallax, the tiny annual wobble in a star's position. Farther out, we climb the distance ladder, separate variables that pulse with predictable brightness. Type 1a supernovae, standard candles, whose peak glow reveals how far they exploded. And baryon acoustic oscillations, BAO, a gentle primordial sound wave imprint that acts as a standard ruler across billions of light years. Each rung overlaps the next, so errors can be caught like mistuned piano keys. Supernovae map how brightness dims with distance and unexpectedly reveal that expansion is speeding up. BAO traces a preferred separation in galaxy clustering, the fossil ring of pressure waves in the early plasma, letting us chart cosmic scale with geometric grace. Meanwhile, strong gravitational lensing, megamizers, orbiting galactic black holes, and tip-of-the-red giant branch stars add fine polish to the rulebook. None of these methods claim an edge. They claim consistency. When multiple instruments hum the same note, we trust the melody. If one drifts, we retune the model, not the universe's shape. The sky becomes a laboratory, candles for light, rulers for angles, timepieces for expansion. For a soothing thought, imagine a carpenter's shop at dusk. Rulers, squares, calipers, all carefully laid out. The craftsman doesn't need walls to trust the measurements. The workbench itself is the reference. Cosmology does the same, measuring a room so large it refuses to end, finding harmony in overlaps, reassurance in repeated chords, and distance in light that knows exactly how bright it should be. Ask the early universe how fast space expands today, and it whispers one number. Ask the nearby universe the same question, and it answers with a slightly faster beat. This mismatch is the Hubble tension, a persistent discrepancy between the expansion rate inferred from early time data, cosmic microwave background, plus the standard cosmology and late-time direct measurements using supernova, Cepheids, lensing, and other distance indicators. Is the cosmos hiding new physics, or are we nursing subtle systematics? Possibilities abound: tiny calibration slips, underestimated dust, complex supernova populations, or more thrilling, fresh ingredients in the universe's recipe. Maybe dark energy is less constant than we thought. Maybe extra light relics beyond the 3 known neutrinos nudged the early expansion. Maybe gravity itself flexes differently on cosmic scales. Attention is not a tear. It's a nudge to look closer, build better instruments, cross-check more rungs on the distance ladder, and refine models. The universe is consistent. Our picture is the thing adjusting, like a camera refocusing in low light. Whether the tempo resolves into one beat or reveals a duet, there's no hint of an edge, only improved sheet music. For bedtime, imagine a symphony where the strings and winds disagree by a hair. The conductor leans in, players listen harder, the harmony tightens. That's cosmology right now. A patient rehearsal on a grand stage, tuning the tempo of expansion until the hall itself seems to resonate with one elegant note. Mass bends space-time, and space-time bends light. Gravitational lensing turns galaxies and clusters into quiet lenses, magnifying and distorting background objects along our line of sight. Sometimes the effect is delicate, weak lensing, a statistical shear of many faint galaxies that maps dark matter like fingerprints on glass. Sometimes it's dramatic, strong lensing, creating arcs, rings, and multiple images of a single distant source. Lensing lets us weigh the invisible, where the images stretch most, mass pools, where patterns align, filaments run. It turns the universe into a relay of natural telescopes, revealing galaxies otherwise too faint to see. Peering at the early cosmic morning, time delays between multiple lensed images of a flickering quasar even give us independent checks on the expansion rate. No lens reveals a border. It reveals structure without edges. Like ripples on a pond betraying submerged stones, lensing maps the landscape by the way it redirects light. The deeper we look, the more we see continuity. A web with knots and strands, not a curtain. For your pillow, imagine moonlight passing through a hand-cut crystal, scattering soft highlights onto the wall. The wall isn't closer, your room didn't shrink. You simply learned the room's shape from the way light dances. Gravitational lensing is that slow silver dance, cosmic light finding graceful paths around gravity's curves and telling us gently what lies along the way. When black holes or neutron stars collide, they ring space-time like a struck bell. Those ripples, gravitational waves, carry an unmistakable pattern that tells us the system's loudness, letting us infer distance directly from the signal's amplitude. Pair that distance with a redshift from an electromagnetic counterpart or a statistical galaxy host, and you've got a standard siren. A new way to chart expansion that bypasses some rungs of the traditional distance ladder. Sirens complement candles and rulers. They don't care about dust, and they read the universe in gravity's own script. As detectors grow sensitive, a choir of mergers will map the nearby cosmos, weigh the Hubble constant, and test gravity under extreme strain. If candles measure by light and rulers by geometry, sirens measure by rhythm, a universal metronome ticking in space-time. Again, no edge appears in the music. We're simply adding another instrument to the orchestra, one that plays in the dark. Each ping from the deep is a milepost on a road that doesn't need a guardrail. For rest, imagine a lighthouse foghorn far offshore, low and steady, telling sailors how far the cliffs are without showing a single rock. Gravitational waves do that for us, distance by tone, position by harmonics, guiding our map-making in a sea whose shoreline never ends, only blends into mist and stars. Why is distant light stretched? Nearby, speeds matter. A galaxy moving through space will Doppler shift its light. But across the great reaches, cosmological redshift dominates. Wavelengths lengthen because the space between crests grows as the universe expands. No need to picture galaxies tearing away like rockets. Imagine the fabric itself dilating under them, turning blue notes to red with time. Could the dimming of distant supernovae be explained by tired light, photons losing energy by some unknown friction? Observations say no. Tired light schemes fail multiple tests. They don't broaden time profiles of distant explosions as observed. They can't match the detailed harmony of the cosmic microwave background. They misfit how surface brightness scales with distance. Expansion, by contrast, nails these rhythms cleanly. Redshift is not a confession of guilt, it's a diary of travel. It records the universe's expansion history on every photon's face. Read enough of those diaries, and you reconstruct the road. No painted lanes, no edge lines, only a smooth widening that keeps pace with the story. To drift off, picture a drawn-out violin note, rich and warm, deepening as the hall itself slowly expands. The musician didn't change strings, the room grew gentler around the sound. So it is with galaxies. The song stretches because the stage breathes, and the score somehow still resolves. The cosmic microwave background is not just a temperature map, it's polarized, carrying a subtle swirl from the last scattering fog. That polarization splits into two patterns, E modes, radial or tangential ripples made by density variations, and elusive B modes, curling signatures that on the largest scales could betray primordial gravitational waves from inflation's first tremor. Finding those B modes cleanly is hard. Galactic dust glows and polarizes, adding foreground embroidery that must be teased apart thread by thread. Lensing by intervening structure also converts some E into small-scale B, a useful probe of mass, but a veil over the inflationary whisper. Experiments in Antarctica, the Atacama, and space are all squinting at the same delicate script, trying to read the first stanza of the universe's poem. Detecting primordial B modes wouldn't show an edge, it would show a beginning's breath. the way early space expanded faster than light without breaking any rules, seeding today's structure. It would turn a compelling story into a measured line. At night, imagine a frost pattern on a window, spirals within rays, hints that the air once moved in a certain way. The CMB's polarization is that frost memory etched in angles. If we trace the curl correctly, we might hear a faint drumbeat from the moment space first decided to grow. Neutral hydrogen hums at a wavelength of 21 centimeters, a quantum flip in its tiny magnetic heart. Redshifted by expansion, that line slides into meter-long radio waves for the earliest epochs, letting us map the dark ages and the first dawn of stars. Instead of single pictures, we get tomography, a 3D movie of where gas cooled, where first light carved bubbles, and how structure matured before galaxies blazed. The challenge is earthly and cosmic. Our planet crackles with radio chatter, the Milky Way hisses. Instruments must be pristine, calibrations monked, but the reward is exquisite. A direct cartography of the fog lifting, a yard-by-yard survey of ray ionization's patchwork, and an independent cross-check on cosmology's parameters. This cartography doesn't draft a coastline. It draws depth, layers of night giving way to day. Each slice reveals continuity, pockets, filaments, islands of light, all stitched together by physics that never asks for a wall. For comfort, picture a dim lake at sunrise. First the silhouettes, then soft reflections. Finally ripples catch fire as the sun breaks. The scene had shape before you saw it. The light only taught your eyes to agree. 21 centimeter cosmology is that lesson, delivered in radio, one gentle frame at a time. Cosmic Fate reads like a choose-your-ending novel. In one chapter, if gravity and matter trumped expansion, the universe could recollapse, a big crunch, rewinding heat and density toward a fiery finale. In another, if dark energy grows more aggressive than a cosmological constant, it could become phantom energy, making expansion accelerate so wildly that galaxies, stars, planets, even atoms are torn apart in a big rip. In the quietest chapter, consistent with what we see, dark energy stays steady and the cosmos dilutes into a big freeze, stars fade, black holes evaporate, and space keeps stretching into a thin, cold hush. Each path is edge-free. Crunch folds time inward, rip pulls scales apart, freeze lets the lights dim. Which script we live in depends on the exact character of dark energy and the fine balance of cosmic ingredients. Observations currently favor the gentle fade, but the book remains open to margin notes. When you rest, imagine 3 paintings in a gallery. One is stormy, spiraling inward. One is kinetic, lines flying out. One is a monochrome that grows paler toward the frame. You can prefer a canvas without insisting the gallery ends at its edge. The hallway keeps going, the lights are soft, the questions wait around a bend. Space may lack walls, but information sets boundaries of a different kind. Black holes carry entropy proportional to their horizon area, the Bekenstein-Hawking insight hinting at a universal holographic bound. The maximum information a region can hold scales with its surface, not its volume. A universe with accelerated expansion resembles de Sitter space, complete with its own horizon and a faint thermal temperature, the Gibbons-Hawking warmth, suggesting that even empty space hums with informational limits. These aren't barricades, they're budgets. They say, within this horizon, only so much can be known, stored, or retrieved. Your personal horizon. What can ever send you a signal shrinks in a dark energy future, not because a wall approaches, but because the stage grows faster than messages can cross. Locally, physics remains crisp. Globally, meaning softens at the edges like starlight in mist. Let that be a lullaby. The universe does not need an outside to be whole. It carries its own accounting, its own soft ceilings, its own ways of saying enough for now. Edges of knowing, not ends of being. Close your eyes and picture a shoreline at night, the tide whispering limits you can't see. You don't need to chart the whole ocean to feel at home on the sand. In a cosmos without walls, enough light reaches us to make a fire, share a story, and drift to sleep beneath a sky that goes. On the grandest scales, matter arranges itself like lace. Galaxies gather into groups, groups into clusters, clusters along filaments, all of it framing vast voids, bubbles of relative emptiness, tens of millions of light years wide. Surveys like cosmic X-rays reveal this cosmic web, a three-dimensional foam where gravity and time have pulled threads taut and left pockets bare. No thread ends in a knot that says, stop. Threads cross, braid and fade, but the loom itself keeps going. How did the web get spun? Tiny ripples in the early universe, minute over and under densities, grew as gravity amplified them. Dark matter, cool and collision-shy, collapsed into scaffolds first. Gas flowed inward along that invisible frame, lit up as stars, and the filaments brightened like city streets after dusk. Voids grew not by shoving matter away, but by matter preferring other roads. Over billions of years, the web sharpened brighter strands, darker hollows, a living cartography with no map border. Stand inside a filament, we do, and every direction shows more structure, as if the universe were a cathedral of arches receding into dimness. Even emptiness participoids are laboratories of gentle physics, places where expansion slightly outpaces the average and galaxies drift with fewer tugs, yet the pattern continues across them too, a faint stippling that never clicks into a wall. For sleep, imagine blowing soap bubbles in slow motion, their films meeting at seams that shimmer but don't imprison. That's the web, geometry discovered, not imposed, a lacework grown from whispers in the primordial fog. When people ask whether space ends, I picture these filaments, roads with no cul-de-sacs, stretching on, dimmer and thinner, but never meeting a painted line that says edge. We can't see dark matter, yet its fingerprints are everywhere. Spiral galaxies spin too fast at their edges for visible stars alone to hold them together. Clusters confine hot gas that should have boiled off. The math insists on more mass, transparent, non-glowing, weakly interact. We map it indirectly by how it bends light, gravitational lensing, and how it sculpts the cosmic web. It's the stage scaffolding, hidden behind scenery, keeping the set upright as the story unfolds. The bullet cluster offered a striking clue. Luminous gas from two colliding clusters slammed together and slowed, but most of the mass, traced by lensing, sailed through with the galaxies, offset from the glowing plasma. That separation hints dark matter isn't just modified gravity. Something unseen carries most of the weight. Particle hunters chase candidates, WIMPs, axions, sterile neutrinos, while astrophysicists watch their collective choreography across the sky. What does this mean for the edge of space? Dark matter doesn't draw borders, it draws gradients. Halos fade, filaments thin, voids widen, but the distribution never clips to zero with a ruler's snap. It's all fall-off, never fence. Where the lensing grows faint, we say less, not none, and even none would invite the next survey to look again with steadier hands. For rest, imagine an orchestra's double basses that you don't quite hear so much as feel, a foundation humming beneath the melody. Dark matter is that bass line. It doesn't solo, and in that support, the universe finds its shape, spirals kept from tearing, clusters from unbinding, a web held in tension across a room with no walls, only deeper quiet. If gravity gathers, dark energy does the opposite. It makes expansion accelerate. The simplest model assigns it a steady density. Einstein's old cosmological constant, a property of space itself. Vacuum with a push. In that case, its equation of state parameter, IBU equals 1 pressure. So negative, it drives the fabric to grow faster over time. Galaxies don't rocket away. The room swells between them, a slow, relentless widening. But what if dark energy evolves? Theories of quintessence imagine a gently rolling field whose energy density changes, nudging Wu to values near but not exactly, one band exactly. Data from supernovae, baryon acoustic oscillations, weak lensing, and the CMB weave constraints like threads in a tapestry. So far, the cloth reads close to COS1, yet we keep checking the dye, the weave, the light. Perhaps the pressure is constant, perhaps there's a quiet tempo shift yet unseen. Does dark energy create an edge? Not a wall, an horizon? As acceleration persists, more galaxies drift beyond effective communication, their new light unable to overcome the growing gap. Locally, everything feels the same. Stars orbit, planets spin, coffee cools. Globally, the stage lights dim at the perimeter, not because curtains are drawn, but because the stage outpaces the actors' voices. For sleep, picture a meadow at dusk. The field doesn't end, it simply fades into evening. Fireflies near you blink cheerfully. Ones at the far fence flicker out of sync until you can't tell if they're there at all. Dark energy is that dusk, soft, widespread, and patient, turning sharp edges into gradations, turning far into too far, and writing our future in italics, quieter, cooler, still expanding. Inflation proposes that, in a fraction of a second after the Big Bang, space expanded extraordinarily fast, faster than any particle could traverse, smoothing wrinkles and stretching curvature toward flatness. It explains why distant regions of the cosmic microwave background share almost identical temperatures, horizon problem, and why the overall geometry appears so close to flat. Flatness problem, a tiny patch ballooned to cosmic size. The universe we see is that magnified fragment evened out and gently dimpled by quantum fluctuations. Those fluctuations are inflation's gift. Seeds of structure, minute jitters in the inflaton field or similar, were blown up to astronomical scales, later becoming galaxies and clusters. Inflation ended in a reheating phase as the field's energy dumped into particles and radiation fire rekindled after a silent, breathless swell. People sometimes imagine inflation as an explosion into pre-existing emptiness. It's subtler. Space itself did the growing everywhere, all at once. No center, no blast front. Just the meter stick changing length beneath everything. If inflation was eternal in some regions, it could spawn many pocket universes with varied properties. A mold idea that whispers multiverse without demanding it. Edges, inflation, erases them. Whatever line existed in that initial speck was ironed to indistinguishability. We inherit a sky with uniformity stitched by randomness, ripples precise in their statistics, generous in their consequences. For comfort, imagine smoothing a crumpled sheet over a bed. The big creases vanish, faint textures remain, enough for shadows to catch, enough for dreams to gather. Inflation is that first smoothing of the cosmic linen, the reason your pillow tonight lies on a universe calm enough to host stars, planets, stories, and a question with no hard outline. Does space end? Even if space is nearly flat, it could still loop back on itself like a three-torus, a room whose opposite walls are the same wall. How would we tell? One strategy hunts for matched circles in the cosmic microwave background, repeated temperature patterns that would appear if light wrapped the universe and reached us along different paths. Another, cosmic crystallography, looks for repeating separations among galaxy positions, like motifs in wallpaper. So far, no convincing repetitions have emerged at the scales we can test, suggesting that if space loops, the loop is larger than our observable patch. Absence of evidence isn't evidence of absence. It's a note on the margin, room bigger than room we've seen. Meanwhile, polarization maps refine the search lensing, reconstructions sharpen the lens. Topology is patient. If there's a seam, it's subtle. A looping cosmos isn't a cage, it's a finite without boundary playground. Travel straight long enough and return without ever turning. No edge, just geometry. If it's truly infinite, then no loops, just unending streets. Both scenarios dodge the need for a wall. One folds, one flows. Both breathe.
As you settle,
Think of a video game where exiting the right edge drops you in from the left. Playful, continuous, oddly cozy. Or think of walking ancient city lanes that circle a hill and return you to the square through a new alley. Each time, topology turns edges into connections. Whether the universe loops or stretches forever, the lesson is the same. We live inside relation, not enclosure. Some cosmic parameters seem finely poised, too much dark energy, and galaxies barely form, too little, and structure collapses too soon. We observe a set of values that permit long-lived stars, complex chemistry, and minds that wonder at 3 a.m. Is that design dumb luck or selection? The anthropic principle offers a modest reminder. Observers naturally find themselves in regions compatible with their existence. It doesn't answer why, but it warns against treating our vantage as typical of all possibility. In a single universe, anthropic reasoning sets expectations. We shouldn't be shocked that we're not in a sterile corner. In multiverse pictures, it becomes a filter. Among many domains, we inhabit one in the habitable range. Like a fish surprised by water temps, a deal for fish. This isn't a permission slip for hand-waving, it's a constraint alongside data, used carefully, never as a first refuge. These reflections don't conjure edges, they clarify bias. We peer from a friendly window and might misread the whole house. Cosmic variance also humbles. With only one observable universe, some questions are limited by sample size. We can know distributions, but not re-roll the sky. For rest, imagine tasting a soup from one spoonful and inferring the whole pot. If the spoon is warm and balanced, that tells you something, but not everything. The chef, the cosmos, may have added herbs you can't detect yet. Anthropic notes remind us to savor the spoonful without claiming the kitchen ends where our taste buds do. Why does time feel like a one-way street? Physics's microscopic laws are nearly time-symmetric, yet we remember the past, not the future. Eggs scramble, never unscramble. The difference is entropy, the measure of disorder, tending to rise. The early universe had astonishingly low gravitational entropy, matter smooth, curvature gentle. As expansion proceeds, clumping, shining, and mixing increase the tally. Stars forge heavy elements. Black holes swallow and store vast entropy behind horizons. An accelerating cosmos approaches a de Sitter-like state. Dilute matter, distant horizons, a faint thermal glow. Black holes slowly evaporate via Hawking radiation, returning their ledger to space's ambient warmth. Far later, even the last photons redshift into wavelengths the size of galaxies. The arrow persists because typical states overwhelm atypical ones. Disorder has unimaginably more ways to be. Speculations about Poincaré recurrences or Boltzmann brains, freak fluctuations that mimic observers, are cautionary tales about taking asymptotic limits too literally. Our universe's actual history is rich with structure built the hard way, not conjured by chance. The arrow is written in galaxies, chemistry, and breaths you can count. Edges? Time's arrow sketches a direction, not a wall. It tells you which way the cosmic wind blows, not where the trail ends. Drift to sleep imagining a beach at low tide, ripples smoothing as the water pulls away. The shore is still there, the patterns change. Entropy climbs like a lullaby crescendo, soft, inevitable, and somehow kind. Black holes are paradox machines. They hide mass behind horizons while radiating like faint coals, hawking radiation implying they evaporate over absurd timescales. Does information about what fell and survive in the outgoing glow? Modern ideas, unitarity, quantum extremal surfaces, the page curve, suggest yes. In principle, though decoding the message is like unbaking a cosmic cake. The horizon becomes less a one-way shredder, more a cryptographic device consistent with quantum rule. Some speculative vistas imagine black holes as seeds of baby universes where extreme curvature pinches off new space-time regions we wouldn't follow. The bridge pinches too cruelly, but the idea entwines beginnings and endings, collapse, birthing expansion elsewhere, a botanical metaphysics of space-time. Even if nature forbids it, the thought loosens our grip on simple edges. Cosmic censorship posits that singular mischief stays hidden behind horizons, preserving predictability for outside observers. Whether or not the principle holds in all cases, the universe acts as if it prefers veils over ruptures, curtains instead of cliffs. For bedtime, picture a library with locked stacks. You can't enter yet the catalog assures the books are accounted for. Black holes are those stacks. Volumes conserved, titles encrypted by quantum librarians. The building has no external wall you can touch, only floors upon floors of rooms connected by rules, stranger and fairer than any hallway we've walked. The edge of knowing, again, not the end of being. Before galaxies glowed, the universe was mostly neutral hydrogen, a fog dimly lit by the cosmic microwave background. Then came population 3 stars, metal-free giants forged from pristine gas. Massive, hot, short-lived, they poured ultraviolet light into the darkness, carving bubbles in the fog. Their death seeded heavier elements, carbon, oxygen, iron, turning future clouds into chemistry sets fit for planets and people. This era cosmic dawn bled into reionization when overlapping bubbles made the universe transparent again. Galaxies and early black holes pushed photons across growing clearings, while the 21-centimeter whisper of neutral gas traced the retreating night. Telescopes now glimpse unexpectedly bright, compact galaxies earlier than some models predicted, prompting fresh calculations. Star formation recipes tuned, dust assumptions revised, feedback reweighed like a baker fixing a batter. Edges don't appear when the lights come on. Contrast does. Structures separate from background, filaments sharpen, voids deepen. The show begins not by lifting a curtain, but by raising the house lights, enough to see aisles that were always there. As you drift, imagine campers lighting lanterns around a lake. At first, only halos on the shore, then paths, then reflections tremble across the water, and you realize the lake had shape all along. The universe's first stars did that, not creating space, but making its lines visible, proof that beginnings are often revelations, not boundaries. It's easy to feel small under a sky with no edges, but small isn't the same as lost. The constellations are stories we tell to navigate wonder. Planets are bright beads threading familiar paths. The Milky Way is our home street filament, a river of suns you can still see. Where the night is dark enough, light pollution can hide it. A short drive can restore the old ceiling, granular textured, infinite without needing a rim. Learn a few anchors. Polaris holds north, Orion's belt points to Sirius and Aldebaran, the summer triangle marks warm nights, and the swan of Cygnus gliding down the galactic lane. Binoculars turn fuzzy patches into clusters, smudges into galaxies. Every object you find is a distance, a time, a paragraph in the universe's book, one you can read without finishing the library. When people ask, does space end? I think of backyard chairs, shared blankets, the hush when someone says, there, and a meteor scratches a silver note across the stave. Space may not end, but evenings do, and that's all right. The comfort isn't in a wall far away. It's in the company close by and the light that traveled so long to meet you. Close your eyes to a sky that keeps going. You don't need to chase the edge tonight. Let the room be big, the questions gentle, the stars enough. Tomorrow we'll measure again. For now, breathe under a cosmos that grows not to keep you out, but to hold you quietly, endlessly, here. Imagine tossing a stone into a pond, rings spread, touch reeds, keep going. Now replace the pond with space-time itself. When massive objects, black holes, neutron stars, spiral together, they send out gravitational waves, ripples in the very geometry of the universe. We've felt the laser arms, miles long, quivered by less than 1,000th the width of a proton, and yet told us of collisions a billion light years away. That's how intimately connected the cosmos is, tensioned like a drumhead with no rim. A ripple seeks no shoreline because space-time offers none. The wavefront expands, its energy thins, but it doesn't meet a wall and bounce. It simply shares its story with larger and larger spheres of night. These waves don't carry pictures, they carry shapes. How masses moved, how orbits tightened, how the final ringdown sang. They add a new sense to astronomy, not just seeing with light, but feeling with geometry. They also confirm a quieter truth. Gravity isn't a force pushing through a medium, it's the medium itself curving, flexing, relaxing. If you want proof that space doesn't end, listen to a wave that began when early hominins napped flint and only arrived after we'd built mirrors precise enough to greet it. The messenger never needed a road. For sleep, picture the sky as velvet water. Somewhere far away, two dark pearls spiraled, and a faint wrinkle began its long, patient commute. It passed galaxies and voids, drifted through our halo, across your ceiling, and through you, harmless, gentle, complete. No tide pools, no cliff faces, just an ocean whose surface is the story. If there were edges, ripples would betray them. Instead, they simply fade into more quiet. Long before the first atoms formed, another background filled space, a flood of neutrinos, near massless particles born when the universe was minutes old. They rarely interact. Trillions pass through your body each second without a whisper. We've caught them from the sun, from supernovae, from Earth's crust. But the cosmic neutrino background itself is too cool and aloof to snare directly. Still, its fingerprints linger in the way matter clumped and the cosmic microwave background rippled. Neutrinos are the universe's ghost wind. They don't sketch edges, they test openness. If space had fences, the patterns of early expansion would skew like breezes piling leaves against a wall. Instead, the distribution we read in light and structure implies an unbarricaded playground, expanding, curving perhaps, but not corralling. Neutrinos also remind us that empty doesn't mean vacant. Between stars and within voids, seas of relic particles drift, cool, thin, but real. Add the deathless photons of the microwave background, and emptiness becomes a hush, not a nothing. Even silence in this universe has constituents. For rest, imagine dust motes in a sunbeam, so many that you stop counting and accept the glow? Neutrinos are dust motes in the dark, an invisible glitter threading every cubic inch of midnight. Their journey never seeks an endpoint, it merely lengthens, wavelength stretching as space stretches, songs played in a lower and lower key. If you could cup your hands and catch the cosmic hush, you'd find it's already around you, passing gently, perpetually, everywhere at once. How do you measure a room with no edges? Astronomers carry candles and rulers. Type 1a supernovae, white dwarfs, pushed to a near-standard detonation, serve as standard candles. Their intrinsic brightness lets us infer distance from dimness. Baryon, acoustic oscillations, fossil ripples from sound waves in the early plasma become standard rulers, their preferred separation etched into galaxy distributions across the sky. Layer candles upon rulers and a map emerges, not a map to an edge, but to a relationship. How distance and redshift entwine. From that curve we learn the universe accelerates. We weigh dark energies push and matters pull. We sense curvatures shy, lean. These tools don't shout end here, they whisper expand thus. Each technique has its own lullaby of care. Calibrating nearby supernovae with Cepheid variables, unbraiding dust from color, modeling selection, tracing BAO peaks amid cosmic noise. The beauty is in concordance, different methods harmonizing on the same cosmic melody. For sleep, picture survey telescopes clicking softly under a dome, their cameras sipping starlight like tea. Tonight they will capture thousands of galaxies, each a dot with a distance encoded in its hue, each pair contributing to a ruler inscribed in statistics. By morning, the map of a boundless room will be a little clearer, not because we've found a border, but because we better understand how far we've come without one. In a universe that expands, distance is slippery. Two useful notions help. Proper distance is how far right now. If you could freeze cosmic growth and lay a tape measure between objects, co-moving distance rides with the flow. It factors out expansion, tagging positions to the cosmic grid like latitude, longitude on an inflating balloon. Light's path complicates things further. A photon leaves a galaxy when it is, say, 3 billion light-years away proper, travels for 10 billion years while the room keeps stretching, and arrives when that galaxy's proper distance is perhaps 20 billion light-years. Did the photon outrun anything? No. It surfed a changing metric, the space beneath it lengthening as it went. Why does this matter? Because edge questions often smuggle in fixed-room instincts. In co-moving coordinates, galaxies retain addresses. In proper, the gaps widen. Horizons, particle, event have clean definitions in co-moving terms. Neither system conjures a wall, both describe a flow. For rest, think of a lazy river. Proper distance is how many meters separate two floats at this instant. Co-moving distance is their place along the painted line on the pool floor. The water moves, the line persists. No dam awaits downstream, only the assurance that some floats drift beyond hailing range if the current speeds up. The river isn't a maze, it's a motion. If space is stretching, why don't atoms swell, planets drift from suns, you from your mug? Because expansion is a large-scale tendency, not a local pry bar, where forces bind electromagnetism in atoms, gravity in solar systems and galaxies. The springs are stronger than the gentle outward pull of the average cosmic flow. Bound systems set up camp on the shoreline and say, we're good here. Even galaxy clusters resist somewhat, though they feel expansions nudge at their edges. Beyond that, on scales of superclusters and filaments, the swell dominates, voids widen, threads tension and thin. It's a patchwork, tight knots, slack gaps, all riding a global drift. Imagine flour in a rising loaf. The yeast lifts the dough, but gluten strands hold pockets together, raisins keep their shape. The air between them grows. Your coffee cup is a raisin, self-kept. The universe's growth acts between such raisins, not within them. For sleep, hold the mug in your palm and feel its certainty. The handle isn't creeping away. The warmth is local, stubborn, kind. Outside your window, galaxies part at centimeters per second per megaparsec, imperceptible here, inexorable there. Both truths share the same room, a cosmos that lets intimacy persist while distances bloom. Please project the movie forward. Star formation slows as gas is used up and locked in remnants. Red dwarfs sip fuel for trillions of years, then wink away. Black holes dominate the ledger, swallowing, merging, and on timescales so vast they mock analogy, evaporating through Hawking radiation. The night's color slides to longer and longer wavelength as expansion stretches every photon into spacious yawn. This isn't an apocalypse. It's a thinning. Gravity still binds local islands. Our galaxy merged with its neighbors while the wider ocean races outward. Event horizons settle in like horizons at sea. Ships beyond them never send you fresh glints. Entropy climbs. Free energy for work dwindles. The cosmic symphony decrescendos. Does space end then? No, it becomes subtle. The absence of new brightness is not a wall, but a hush. In some speculative tales, dark energy changes character, or vacuum decays, or new inflations bud branch stories we can't confirm. In the standard telling, the universe ages into transparency and patience. For rest, picture a winter field after snowfall. Sound damped, shapes soften, the day's last warmth giving way to a clean, endless blue. You can walk as far as you like. The fence posts don't multiply, they recede. If forever has a feeling, it is this. Not boundary but breadth, not ending but ease. Mass bends light. Place a galaxy cluster between you and a farther galaxy, and the cluster acts as a gravitational lens, magnifying, distorting, even making multiple images of the background source. Our best deep fields borrow these natural telescopes, peering farther than mirrors alone allow. Arcs and halos become clues. We invert their curves to weigh dark matter and sharpen distant portraits. Lensing proves something elegant about the room we inhabit. It has curvature without casing. The pathways of light bend where mass resides, not where walls intrude. Mirages in deserts suggest warm air, not glass pane. Cosmic mirages do the same. Every arc a fingerprint of gravity, not architecture. Strong lensing, dramatic arcs, and weak lensing, subtle shape, shears across millions of galaxies, both read the same script. Structure cascading from tiny seeds, pools of mass hidden and revealed by how they guide photons. No end of space is ever implied, only more along the way. As you drowse, imagine walking a marble hall with floors so polished they reflect the ceiling's frescoes. Curves fold images into arabesques. Corners stretch paintings into ribbons. You don't assume the palace ends where the reflections twist. You assume the light is playful. The universe is that hall, endless enough for echoes, intricate enough for... Why is the night sky dark if stars abound? Partly because stars are finite and far, partly because the universe expands and ages, and partly because dust and gas sip light along the way. Not enough to black paint the cosmos. If dust fully trapped starlight, it would glow and re-radiate, but enough to redden, soften, and hide. Dust isn't dirt. It's the glitter of death and birth. Carbon soot from giant stars, silicate ash from supernovae, ices in cold clouds. It turns nebulae into lantern shades, sculpts pillars and lanes, seeds planted. It dims without deceiving. We correct its veils with color, infrared eyes, and patient models. Dark, then, is not a lie. It's a texture. Some darkness is distance. Some is expansion. Some is the honest shadow of tiny grains that will someday be beaches on worlds not yet warm. None of it is an edge. If anything, darkness testifies to depth. For rest, think of a fogged window lit by a street lamp. Halos, softened outlines, a sense that more exists beyond the blur. You don't suspect a wall, you sense weather. Cosmic dust is that weather. Part nuisance, part nursery, wholly belonging. Sleep under a darkness that means there's more, not there's no more. Ask two travelers moving fast relative to each other to agree on what events are simultaneous, and they'll disagree quietly, rigorously, inevitably. Relativity of simultaneity says there is no universal now slicing the cosmos. Each observer's plane of present tilts with their motion and the gravitational fields they traverse. Time and space are woven, and the pattern depends on how you walk the loom. Why does this soothe an edge worry? Because where does space end? Often smuggles, right now, everywhere, a phrase the universe doesn't endorse. Distances depend on when you measure, horizons depend on which world line you live. The cosmos resists being stamped flat. This isn't chaos, it's consistency. GPS satellites correct for it every day, their clocks tickled by speed and altitude. Your phone maps your street because Einstein's math keeps time honest. If relativity governs rush hour navigation, it can cradle your bedtime metaphysics. For sleep, imagine two friends texting across a valley while hiking different switchbacks. Each sees the other's now as slightly slanted by path and pace. Neither is wrong, both are local. The mountain contains them without choosing a favorite time. Space is that mountain. Broad, calm, impartial, happy to host many nows, none of them at the edge. Edges or not, the sky is best met with practice. Keep a small notebook, dates, times, a sketch of the moon's horns, the first time you saw Saturn's ring as an ear, the meteor that made you gasp, note colors, Betelgeuse's ember, Regel's ice, Antares's rose. Track the Milky Way season, spring's lean ribbon, summer's bright river, autumn's arch, winter's hush. Each entry is a stitch tying you to a cosmos that doesn't need borders to feel like home. Try rituals, a blanket in the same spot, one deep breath before you look up, a minute of silence after. Learn 3 new objects a month, a cluster, a nebula, a galaxy. Share them, point with an open hand, and say, there, watch someone you love see for the first time. Edges fade in the face of belonging. When you know Orion's belt points to Sirius, when you can hop from Andromeda's smudge to Cassiopeia's chair, space stops being an abyss and becomes a neighborhood with long streets, sure, but also porches and familiar corners. As you close your eyes, let tonight's diary be short. Clear, cool, 1 satellite, 2 meteors, Jupiter bright, no edges, just enough. Tomorrow, the questions will still be there. Tonight, let the answers be simple. You are here, the room is vast, the lights are kind, and the darkness between them is not a void, but a place for rest. Even without walls, we try to take the universe's portrait, but our camera, Earth, in one tiny bubble of space and time, only sees a particular patch. Cosmic variance is the gentle reminder that some things we measure, like the largest scale ripples in the cosmic microwave background, are partly luck. The roll of the cosmic dice in our neighborhood of the infinite quilt. If we lived a billion light years away, the pattern would rhyme, but some threads would cross different. This isn't failure, its statistics in a vast. On small and middle scales, the sample size is enormous. Millions of galaxies, billions of years. So trends emerge clearly. On the grandest scales, we have just the one sky. Like tasting soup from a single spoon, most flavors reveal themselves, but a few subtle spices might hide near the bottom of the pot. Cosmic variance soothes the edge itch because it shows how the universe resists a single definitive snapshot. The room isn't boxed, it's big, and big means patchy, not because it ends, but because it's rich. We hedge with error bars. We combine multiple surveys, we compare independent methods until a melody persists through the noise. For sleep, imagine lying on a beach at night, counting waves. Some break evenly, some arrive offbeat. A far tanker's wake muddles the rhythm. You don't demand an exact period, you feel the sea. Our cosmology is like that. Good averages, honest scatter, and a calm acceptance that a vast ocean won't clap to a metronome. No shoreline required, just patience and the quiet skill of listening long enough for patterns to appear. Quasars, brilliant black hole lighthouses, shine from the deep past. Their ultraviolet photons cross billions of light years, weaving through filaments and voids. Along the way, clouds of intergalactic hydrogen sip specific wavelengths, carving tiny bites in the spectrum. Line after line, like teeth marks, builds the Lyman alpha forest, a barcode of the cosmic web itself. Each notch records a cloud's redshift, its distance and epoch, temperature and density. Stack hundreds of quasar spectra and you sketch the fog between galaxies, the intergalactic medium normally invisible. You see filaments as strings of absorption, voids as broad clearings, and motions as subtle smears. It's cartography by lantern light, not mapping continents, but the mist between them. Notice what this method doesn't find: walls. It reveals structure, hierarchies of clumps without hinting at a universal fence. If anything, the forest's reach argues for depth. The same physics repeats. Cool gas, heating from galaxies, enrichment by old stars, expansion stretching every line to redder notes. The further we read, the more the tune holds. For rest, picture walking through a grove at dawn. The sun is low, shafts of light thread the leaves. Dust glitters in the beams. You see the air by how it dims the ray, not by seeing the air itself. The Lyman alpha forest is that grove, written in spectra, tender, detailed, endless. You don't look for the forest's edge, you follow the light as long as it lasts, learning the path by the rhythm of shadows and the hush between trunks. Distant supernovae don't just look dimmer, their light curves look longer. A Type 1e explosion nearby brightens and fades on a well-known schedule. Far away, high redshift. The same pattern is stretched in time by exactly the redshift factor, a graceful confirmation that cosmic expansion dilates not only wavelength but durations. This cosmic yawn is a kind teacher. It says, your instincts about ticking clocks are local. On the grand floor, the carpet slides under everything. Colors lengthen, beats relax. There's no trick, only geometry. The universe isn't rushing matter through stationary time. It's rescaling the stage where time and space share threads. Time dilation helps standardize candles and sharpen distances, but it also hushes the edge, anxiety. The farther you gaze, the more ancient and slowed the fireworks appear. Beyond some reach, the party's newest sparks will never arrive. That's not a wall, it's a tempo change. The quieting of a band you can still hear but can no longer join. For sleep, imagine a street musician 2 plazas away. The melody reaches you softened by arches and distance. Notes linger, tempos relax, the echo rounds hard corners. You know the song shape without hearing every crisp attack. Distant supernovae sing like that. Truth intact, edges softened by the space between, no fences, just the wide colonnade of time. Cosmic voids are vast, faintly under dense regions, tens to hundreds of millions of light years across, where galaxies are sparse and distances breathe. They aren't holes, they're hollows, the gently swelled places between threads of the cosmic web. Paradoxically, they clarify the universe's openness better than clusters do. In voids, expansion runs a touch freer, gravity's brake is lighter. Galaxies at the edges seem to lean away, and peculiar velocities draw matter from the hollow toward surrounding walls. Voids evolve, merging, softening, like soap bubbles, relaxing their foamy tessellation. They are laboratories for dark energy's push and modified gravity's whispers. Because subtle effects stand out where little else tugs. Look through a void and you see farther than average. Weak lensing, there is a delicate defocusing. The microwave background gains tiny temperature tweaks as photons cross changing potentials. Every signature says the same thing. The room grows, the corners do not sharpen into barriers. For rest, hold the image of a countryside at dawn. Fields mist smooth, hedgerows outlining gentle bowls. Birds gather along the edges, the centers lie open, quiet, blue. You could walk those meadows all morning without finding a fence. Only the suggestion of shape given by what gathers elsewhere. Voids are that meadow, the universe expressing spaciousness, not as lack, but as calm. A young universe glows in blue, hot, massive stars, birthing in messy gas, galaxies colliding like gleeful toddlers. Over time, fuel dwindles, feedback from supernovae and black holes warms and expels gas, disks settle, mergers sculpt spheroids, star factories dim, populations age from blue to gold to red. Quenching is not a wall, it's a maturation of ecosystems under changing resources and rules. We track this with deep surveys. The main sequence of star formation shifting, the mass metallicity relation evolving, morphologies transforming. We see dusty starbursts lighting up for a frantic 100 million years, then embers. We see quiet ellipticals fossilize starlight into smooth halos. We stack spectra, count clumps, and stitch a time-lapse of a cosmos learning restraint. This arc mirrors the expansion's patience. Galaxies do not blaze to an edge, they age into it. The night ahead is not empty, it's seasoned. Fewer fireworks, more hearths, even black holes calm, radiating softly as they sip rather than feast. For rest, think of a city as evening falls. Neon yields to window lamps, rush thins to footfalls, kitchens hum. The skyline doesn't end, it warms. Galaxies grow up the same way, less shout, more glow, filling space not with a stop, but with a slower kind of light. Edges and horizons are cousins, not twins. A black hole's event horizon is a true one-way membrane in space-time. Cross it, and all future paths point inward. That boundary is local, absolute, and carved by crushing curvature. By contrast, the cosmic event horizon is a global, observer-dependent limit set by expansion. Beyond it, light emitted now will never reach you, though past light might still arrive. One horizon traps, the other outpaces. One is a cliff, the other is a current too swift to swim against. Neither is a wall in the carpentered sense, and only one around black holes feels like a tangible boundary. The universe can host real horizons without being a box. It can sketch limits on influence without stapling plywood to the sky. Gravitational lensing rings, accretion disks, and jet beacons outline black holes for us. Clean circles where night is final, cosmic horizons leave subtler signs, reddening into radio, vanishing of updates from faraway galaxies, a statistical hush. For sleep, hold two images, a deep well whose mouth you dare not pass, and a broad river whose center runs faster than any boat. The well is a black hole, definite, intimate. The river is the universe, open, powerful, and endlessly moving on. Both are beautiful. Only one pretends to be an edge. If space loops on itself, finite yet unbounded distant regions might be the same place seen along different paths. The cosmic microwave background could then show matching circles in the sky, pairs of rings with identical temperature patterns stamped at different angles. Astronomers have looked, crafting algorithms to compare newly across the whole celestial sphere. So far, no convincing twins. That suggests the universe is either larger than the observable part, so loops, if any, exceed our view, or simply not multiply connected in a small way. It doesn't prove infinity. It pushes the minimum size outward, like tapping walls in a dark room and hearing only silence. You conclude if there's a boundary, it's farther than your stick. Toba-P tests soothe with their honesty. We ask sharp questions and accept soft answers. Bigger than this, rounder than that, no obvious mirror. We refine, try again, let the map expand. For rest, picture wandering an unfamiliar cathedral, tracing steps to see if corridors rejoin. You leave a chalk mark, walk, return, no mark in sight. The space may still circle, but not within the halls you've paced tonight. You shrug, light a candle and sit. Vastness doesn't need to boast. It simply exceeds. Another way to weigh expansion is to ask the universe its age in many voices. Old star clusters in our galaxy carry clocks in their faintest white dwarfs. Radioactive isotopes in ancient stars whisper half-lives. Passively evolving galaxies act as cosmic chronometers, their stellar populations aging at rates tied to the Hubble flow. Compare ages at different redshifts, and you infer how quickly the scale factor grows. No ruler, just time. This cross-examination matters. If our expansion story were wrong, ages would quarrel, a galaxy too old for its look back, a cluster older than the cosmos. Instead, numbers harmonize within uncertainties. The metronomes agree. Expansion accelerates gently under dark energy's hand. Matter slows it modestly, and the whole symphony began about 30. Chronometers don't reveal edges, they reveal consistency. A room without walls can still keep good time. We nap easier knowing the clocks on different shelves tick the same tune. For rest, imagine a house at night. Grandfather clock in the hall, a wristwatch on the dresser, the soft blink of an oven timer in the kitchen. You listen from the couch and hear them sync, not perfectly, but enough to know the hour. The house has many rooms. None needs a door to agree on midnight. When two neutron stars collide, they ring space-time with a precisely modeled gravitational wave. That waveform encodes their absolute scale, how bright the sound was at the source, so measuring its fading gives a distance without candles or ladders. If we also catch light, a kilonova's glow, and a redshift, we've built a standard siren, a fresh way to chart expansion.
Sirens matter because every independent yardstick redraws the same coastline. When gravitational waves, supernovae, baryon acoustic rulers, and chronometers all sketch the same curve, faith in the map grows. Disagreements, like today's Hubble tension between early and late universe measures, become productive puzzles, not portents of walls. They nudge new physics or hidden systematics into the light. Sirens travel unbothered by dust, indifferent to intervening gas, carrying geometry itself. They don't seek edges, they sample space as weave, direct. For rest, hear a lighthouse horn rolling over fog,
a low, steady note. You can't see the shore, but the sound swell tells you how far. Add a faint lantern flicker, and the picture sharpens. No cliff face appears, just confidence in where the harbor lies. Even when the sea is very wide, imagine a starship that never tires. It accelerates gently, flips, slows, repeats, decades into centuries, eras into elegies. You watch the local group coalesce into one milky island. Beyond, constellations deform as expansion stretches the backdrop. Each year more galaxies read out of visibility, their newest light forever late. Your charts keep updating, then updating less. The sky simplifies, not to emptiness, but to home. No matter how valiantly you thrust, the cosmic event horizon is not a line you cross, it's a limit on news. The ship moves, the river quickens, you reach places, you lose broadcasts. The journey has no cliff, only a thinning conversation with the far away. In the observation bay, you pin a map from your first voyage next to the latest. The early one is busy, the new one is intimate. Both are true, both are beautiful. Space didn't end between the versions. Your relationship with it changed. For sleep, climb into your own starship. A bed, a window, a mind that can travel without moving. Let the far edges soften into kindness. Let the nearby lights keep you company. If the universe has a lesson for travelers, it may be this. There is more than you can visit and enough for you to love. No walls, only way, stretching, humming, and at last, very gentle. When people ask if space ends, they often picture a cliff. Physics suggests a gentler ending, not a wall, but entropy. The universe trends toward evenly spread energy, no big temperature differences, no eager gradients to power stars or storms. It's called heat death, a phrase that sounds dramatic but feels more like snow slowly muffling a busy city until the sounds soften and stop. Right now, the cosmos is lively. Galaxies sparkle, black holes feast, gas rains down and ignites new suns. But over unimaginable timescales, fuel thins, star formation wanes. The brilliant fireworks calm to warm embers, then to rare blue-white sparks, then to long, quiet cooling. Black holes will dominate the final act, nibbling and merging, radiating faint hawking whispers across a canvas already dimmed by expansion. None of this installs a border. The universe keeps expanding, stretching wavelengths, diluting light, thinning the drama. Ending here means approaching a state where changes slow to a crawl and novelty becomes scarce. The room remains, the conversation fades. There's an unexpected comfort in this picture. It says, the cosmos is lawful and patient, no trapdoor, no abrupt stop, just a long exhale. We see hints of that future even now. The average star is small and steady. Most matter is dark and quiet. Most volume is empty and cold. The universe knows how to rest. For sleep, imagine a campfire at the end of a night. Flames settle to coals, coals sink to glow. Glow becomes a memory in the air. You're still under the same sky. The forest doesn't end when the fire does. It simply grows still. Space is like that. No edge, only an asymptote. An ending that's really a soft, endless after. Today, the sky holds a background warmth. The cosmic microwave background, the oldest light we can see. In the far future, that glow redshifts past microwaves to radio, then beyond any practical detector, stretched by expansion into a hush. Galaxies we can photograph now will drift beyond our event horizon. Their newest signals forever late. Night won't be empty. It will be quiet. Astronomers sometimes call this the end of cosmology. Not because the universe stops, but because evidence grows too thin for curious beings to reconstruct its story. Without the CMB's faint pattern or distant galaxies retreat, future skywatchers inside a merged Milgdromeda might conclude the cosmos is static and small. Their view would be honest and incomplete because of timing, not talent. Redshift is the engine behind this soft vanishing act. As space expands, each photon's wavelength lengthens, energy tick by tick diluted into gentler hues. The message isn't erased, it's translated into a dialect too stretched to hear. Like an echo in a long canyon, it persists while edging past audibility. There's melancholy in that, and also grace. We live in a rare middle era, old enough to read the universe's baby photo, young enough to see distant galaxies still waving from the porch. When you step outside tonight, you're catching a performance perfectly staged for understanding, not too loud, not too quiet. For rest, picture a lighthouse far across water. Early in the evening, its beam slices the mist. Later, fog thickens and the light becomes a faint pulse. Then a rumor, the sea doesn't end. The fog rephrases it. Our cosmic fog is redshift. It doesn't build a wall. It lengthens the syllables of light until the night speaks in whispers only the universe remembers. Space curves, and curved space bends light. A galaxy cluster can act like a lens, magnifying a remote galaxy's glow, splitting it into arcs, or even cloning it as delicate multiple images. This gravitational lensing doesn't suggest an edge, it reveals depth, foreground, midground, background layered like panes of crystal. Strong lensing paints dramatic crescents and Einstein rings. Weak lensing, subtler, tilts galaxy shapes by a percent here, a whisper there, add millions together, and the cosmic web's mass fields appear, including dark matter's invisible scaffolding. Light becomes a surveyor, tracing hills and hollows in space-time we cannot touch. What's striking is the continuity. From nearby groups to far-flung clusters, the same lensing laws apply. No rim interrupts the optic. The more mass we map, the more structure extends. Filaments feeding clusters, voids widening, halos merging, like frost on a window pane spreading with exquisite patience. Lensing also rescues the faint. Behind a massive cluster, the universe allows us to spy galaxies too far and too small to see otherwise. Infant star cities from when the cosmos was a toddler. We aren't peeking over a fence, we're looking through a curved window. For rest, imagine sunlit ripples on a pool dappled by a glass sculpture. Patterns skitter, bright and bending, not because the sun stutters, but because the glass is shaped. The sky's glass is gravity, smooth and honest. It warps what we see without lying about what's there. In a room with no walls, lensing is the play of light across curves, proving that the way to know a space is to watch how it deflects a beam and to trust that a beam crosses farther than any hand can reach. Before atoms formed, the hot plasma of the young universe rang with pressure waves, acoustic oscillations as gravity pulled matter inward and photon pressure pushed it out. When the cosmos cooled enough for light to decouple, those waves froze into the matter distribution, leaving the preferred scale about 50 megaparsecs today after expansion stretch. We see it as a gentle bump in the galaxy, two-point correlation function, the BAO feature. BAO is a cosmic ruler. Measure that bump at different redshifts and you trace how distances grow independent of candles or sirens. It's humble, no crescents or fireworks, just a statistical nudge saying galaxies are a touch more likely to be this far apart. Stack surveys SDSS, BOSS, EBOSS, DESI, and the nudge sharpens into a dependable yardstick. Rulers matter in rooms without walls. If every independent tape measure agrees on the floor's expansion, You trust the floor even when its edges are out of sight. BAO plays well with other instruments. Supernovae set tempo. CMB sets the overture. Lenses sketch the mass. Sirens thrum the bass. Together, they narrate a universe that expands smoothly and accelerates gently. No hidden barricades, just more floor. For rest, imagine marking tree rings. Each ring a record of growth, the spacing a climate diary. You don't need to see the forest boundary to learn its history. The BAO ring is like that, an imprint of ancient sound turned into distance, a quiet pulse, born in the first few 100,000 years and still present between galaxies tonight. It's the universe saying, I remember my first heartbeat, and the rhythm still guides my steps. Long before light could travel, neutrinos slipped free. These nearly massless particles barely notice matter. They pass through planets and people as if through fog. A relic cosmic neutrino background should permeate space today, cool, abundant, and shy, carrying the thermal memory of the universe at 1 second old. We haven't directly caught that background yet. It's too cold, too faintly coupled. But its footprints show up. The CMB's delicate ripples encode neutrinos' early free streaming. Big Bang nucleosynthesis, how much helium and deuterium formed, prefers a specific neutrino count. Large-scale structures' growth is slightly suppressed by neutrino motion, smudging tiny clumps. Added up, and the ghosts are statistically present. A quiet sea beneath the photons glow. Why does this matter? For edges. Because the more invisible the ingredient, the more convincing the continuity when it appears everywhere. Neutrinos don't pile up at borders. They drift through. Their story strengthens a vision of space as a medium with properties, Tutterbeck histories, particle relics, rather than an empty nowhere. For rest, picture dust motes in a sunbeam. You don't feel them, you barely see them, but in the slant of light, their dance gives the room a secret depth. Neutrinos are that dance at a cosmic scale, pervasive, whispering, honest. The universe isn't empty between galaxies, it's occupied by histories. And even if your hand passes through them, your equations clasp them gently, like the memory of a scent you can't quite name but know is real. After recombination, the universe entered the cosmic dark ages. Neutral hydrogen filled space, and without bright sources, there was little to see. Then gravity gathered gas, the first stars ignited, young galaxies and black holes flooded space with energetic photons. They reionized hydrogen, carving glowing bubbles that expanded and merged until the fog lifted. We trace this dawn in many ways: the Gunn-Peterson troughs in quasar spectra, the patchy polarization of the CMB, 21-centimeter experiment straining to hear the hiss of neutral hydrogen recede. Reionization wasn't a switch. It was weather storms of light clearing over eons, uneven and beautiful. Notice the pattern. A universe that changes phase without installing walls, neutral to ionized, opaque to transparent, quiet to luminous. Each transition alters how far we can see, not whether there's anything beyond. First, light doesn't reveal an edge. It enlarges the room we can navigate. For rest, imagine morning fog over water. A few boats turn on lamps. Halos form around them. The halos grow, overlap, and suddenly you can see the far shore you suspected was there all along. The shore didn't arrive with the light. The light arrived to show the shore. Reionization is that morning. Our telescopes are the patient watchers at the dock, counting lamps, timing halos, and smiling when the day finally breaks across a sea that never had a wall. If you like simple stories, try this. The universe has a single, gentle function that tells how big distances are compared to some past moment. It's called the scale factor. When a t doubles, all unbound separations double. When it accelerates, redshifts deepen and horizons tighten. When matter dominates, a T grows like T to 2, 3. When dark energy leads, it slides into near exponential calm. The Friedman equations relate to what the universe contains: radiation, matter, curvature, dark energy. Hand them densities, they hand you a breath. Slow inhale, quicker inhale, smoother inhale. No bang against a wall, just the tempo of growth governed by energy and geometry.
You feel the consequences everywhere. Supernova light, curves, stretch, because it does. BAO spacings, inflate because it has. The CMB's peaks fall where its A's. History puts them. Lensing kernels, galaxy ages, siren distances, all are choreographies danced to eights.
For sleep, imagine a chest rising and falling. You don't need to know every cell's chemistry to sense the rhythm. The universe's breath is a T. It began fast and hot, cooled and slowed, then found a new, steadier pace under dark energy's palm. If there's an edge to be found, it isn't spatial. It's in the equations, when terms fade, when others matter. A room can be boundless and still have a heartbeat. A stay is that pulse, quiet, regular, and very, very old. In a few billion years, the Milky Way and Andromeda will merge, their stars mostly passing unharmed, their dark halos blending, their gas throwing brief fireworks before settling. The result, a big, quiet elliptical or a smooth disk, an island galaxy adrift in a universe whose far lights are slipping out of reach. The local group will tighten, satellites will rein in, central black holes will meet, ring space-time like a bell, and sleep. As eons pass, starlight reddens, dwarf galaxies trickle in, the broader cosmic web grows visually thin as expansion steals away new messages to future astronomers. The sky will feel intimate. Most of what we study now will be history without signals. This isn't enclosure, it's becoming local. The cosmos doesn't shrink. The conversation does. Like a town after the highway reroutes, the streets remain, traffic lessens, the night is quieter than you remember. The universe invites us to cherish what is near because the far will grow shy. For rest, picture a lake house in winter. Summer's boats are gone. The water is steely. The house is not lonely, just itself. A lamp in the kitchen reflects on the glass. Someone turns a page. You don't need distant fireworks to feel at home. In the long future, Milkdromeda will be that lamp, enough light to read by, enough sky to love, and a horizon that's really just the gentle edge of news. Some boundaries are not in space, but in knowledge. We can't see before recombination with light. We must infer with neutrinos or gravitational waves. We can't sample beyond the event horizon. We solve equations outside and trust continuity within. We can't sample beyond the event horizon. We solve equations outside and trust continuity within. Philosophers remind us a horizon isn't failure, it's a coordinate choice. We define what can be known from here, now, with these instruments, this biology, this finite lifetime. Tomorrow's here now will be wider new messengers, low-frequency waves, 21 centimeters, relic neutrino detectors will move the line. The room doesn't add walls, we bring bigger lamp. It helps to be gentle with uncertainty. Good science loves error bars. Good sleep loves permission. You can rest without a map of everything. You can wonder honestly and then close your eyes, trusting that the universe keeps being itself, whether or not you've labeled all its corners. For rest, imagine a shoreline at dusk. Fog sits on the water. Beyond the buoy, vision fades. The ocean doesn't end at the fog. A bell sounds, and you believe the rest by the ring. In cosmology, bells are data. Fog is limit. The sea is space. We work, we listen, and we let the parts beyond our reach be beautiful anyway. We've walked a long circle. We met horizons that limit news, not existence. Rulers stamped by ancient sound, lenses and voids, first lights dawn, neutrino ghosts. The universe is breath. Each step said the same simple thing: space doesn't need an edge to be real. It can be finite yet unbounded, or effectively infinite. It can expand forever and still hold your hand. If there's an end, it's the way a song ends, by fading, not by striking a wall. Redshift lengthens syllables, entropy settles the drums, far galaxies bow out politely. The stage remains. So does space end? Not like a cliff. What ends are certain conversations, new light from far shores, the bright youth of galaxies, the ease of reading the early script. What continues is space itself, curved, humming, threaded with fields, a patient fabric that lets things be and keeps on letting. For sleep, imagine this. You're floating in a planetarium after hours. The projector dims, the last stars linger. The dome is still there, smooth and silent. You breathe with it, slow, even grateful. Somewhere, photons older than continents are still crossing the dark to find you. Somewhere, a future mind will ask you a question and smile at the same answer. No edge, only way, only light taking its time. Only a universe that doesn't stop, because the best stories don't need to. They just keep opening until you're ready to close your eyes.